All right, is it time? Check the mic levels. Hello. All right, and ready to go. Yeah. So where are we? We're back to work on the game engine. I have done a little bit of work over the weekend, mostly on experiments that will probably be useful going forward. But where we last left off, we were working on the texture inspector. So if I open up a scene, we've got the same scene that we've been using for weeks and weeks, 3 sprites per row, and this is loaded from an entity file. We have an inspector on the left that lets us change certain properties. Now, though, the textures are loaded through texture asset files. So if we take a look at those, they are basically just YAML files that contain, let me do the language parsing. I should probably associate .eptext with YAML. At some point I'll go through and actually tell VS Code to start treating this extension as YAML, but I'm still kind of, I'm not really finalized in a whole lot of things, so I'm kind of holding off on doing things like what my file extensions should be. But yeah, basically a YAML file contains the type of the texture, contains any paths needed in the texture, contains the min, mag, and mipmap modes. Min filter, mag filter, and mipmap modes. We have a line for clamped, but it's not in use now. We also have a line for lines for the slice values and the projection, which are also not in use yet because they are for texture types we haven't got support for yet. But we do have support for magnification, filter modes, and mipmap levels. So in the case of Link, which we have an inspector over here as well, so we can see what's in the file. In the case of Link, we just check texture2, because text2.png, which is what it references as the Link sprite. The minification and magnification filters is linear, and so it's mipmap mode, and that's why he's blurry, whereas these guys are not. I haven't really done much work on this at all. I did late last night hop in and throw in a path field, a simple one line path field that displays the first entry inside of the paths list inside of the EP texture files. This is going to be a little bit more complicated to fully implement because we're going to need to make this basically a widget type that we don't have built in natively to DRIM GUI. I'm going to be making some kind of advanced widget where it's like an array of strings where you can edit each string, and you can also reorder them by dragging a little handle. But there's nothing like that native in DRM GUI so far as I can tell, so we're gonna have to do some hard coding for that. But I'm putting that off for another day because that's not really the priority right now. The priority right now is to get the inspector API finished and to get serialization figured out. And so in the case of textures, this is not, when we're working with sprite components, for example, this is a component type that is basically just a placeholder for whatever game systems you want to develop, whatever renderers you want to develop, and perhaps any vanilla renderers that I will ship with the engine. But the point is that this is something that's optional, something that's going to evolve. I'm not actually committing this to the engine layer. That's not the case with texture files, because textures and texture assets are a core engine feature. You use them as an element of your renderers. You don't define your own texture types, though you could if you wanted to. I don't see why you would want to. So yeah, this stuff we're actually going to be having to commit. I also went in and did the code for setting these fields to be multiple values. So when I go to select multiple eptext files, we'll see that it says multiple values inside of the path field. That's because this one says text2 and this one says text1. This is something that this mixed field widget is something that we added a couple of streams ago, like I think it was like a week and a half ago. However, we have yet to do that for the drop downs. So this morning I'm gonna implement the drop downs, so that way when they are mixed, it'll like show like dashes or something like that, or maybe it'll say multiple values in text the way that the text field does. I don't know. That's something that we'll have that support for. Yeah. Anyway, right before the stream started, I kind of started on the teensiest little refactor. I found online that selectables actually do have a preferred way to double click. Omar for the DRM GUI library indicates that if you're using a selectable, then the best way to tell when you double clicked on it is to set the double clicked flag and then call is double clicked on it when it returns true. So that's what I'm doing here. Because now, since we added the whole selectable icons thing, the icon boxes that we interact with are now IMGUI selectables. So I can actually provide the allow double click flag and then call is mouse double clicked on it to determine whether we've double clicked. That just meant reordering the code a little bit. I'm just going to wrap that up real quick and then we'll move on to the other stuff. All right. I think I've mostly got it. One thing is this isdir question. Isdir is determined at the very start of this loop. So we're looping through all the files that we pulled from the system. And we're not pulling every frame anymore, but we have a list of all the files that are in the active folder. And we use isdir to determine which icon to draw, and we use it to determine the double click response. So if we double click on a directory, then we change the current level. We go up a level, we set the current path to the path that we have selected. And then refresh path cache will actually go and tell the engine to pull the folder. That's the new current level, new current path. And then we break, meaning that we get out of this for loop where we're iterating through these files because that list is no good anymore since we changed levels. And before we do that, we use pop ID. And this is something I like about this refactor is that push ID and pop ID, I can fit them in the same screen now, so it's a lot more clear that this is where the loop closes. You can just see it at a glance. But yeah, everything else seems to be okay. I'm not seeing any red squiggles on the IntelliSense. Okay. I think that's pretty good. And we have an invisible button for the file names, just because I wanted to have a box that would cut off at 2 lines, but that's not super critical right now. So let's kill the program. Let's press F7, and let's confirm I didn't just break everything. I'm sure it'll be fine. This is a simple change for the most part, even though it does mean reordering the logic a little bit. There it goes. Compiled successfully. Press F5. That's looking good. Double click on the folder. Aha! Okay. That's good. And then we can open up the texture files and the scene files. Cool. Now this actually takes care of a problem I was kind of wondering about, and I'm really glad that it's better now. There was something I noticed where when you go to double click on a folder to open it, if your cursor was over an icon, the previous way that we were doing double clicking, it was where we just detect whether we double clicked and whether we've moused over instead of handling it as a response to the double click or to the selectable itself. I found that it would automatically select the icon behind it as if I had just single clicked on it, and that was wrong. And this is far better. It is now, when I double click, it's not changing the levels. That is, it's not changing what I've got selected. It's still selecting the folder in the upper directory. Sweet. All right, and we're ready to move on again. Though I do want to point out one quick little change that's making my life a little bit easier for now. I quickly hacked together a way for me to go up a level, and that's just for me to press the back button on my mouse. I did that by, if I head back to the content browser code, there was an area in the code where when we were looking at deselecting everything, that was, where is it? Here it is, deselect all when user clicks empty space. Basically in the main area, I just have the is mouse clicked left while not holding shift and control, and while we aren't hovering over anything, and while we are within the bounds of the window. This, I basically just took and repeated the code down here, removing most of those conditions, so that way if I click the back button anywhere in here, it will go up a level if we are not currently at the top level. So just a easy way for me to not have to go click the back arrow manually. I can just go in and back button out. Not truly a back button because it's not using a navigation history, which we'll eventually get to. But for now, this is good enough. Sweet. So the next task is to get DRI and GUI to show dashes on these. This is really just to make sure that the fields function correctly. I can't really. It's really hard to confirm whether I'm doing multi-selections if I don't see a visualization inside of the editor. So when I select eptext 1 and 2, I made these properties different on purpose. I want them to show dashes. So let's look at how to do that. All right. So for starters, the code in question is going to be in textures.cpp. And here we are with the combo boxes. So the min filter combo, the mag filter combo, essentially the same thing as before, with the one exception that the is mixed variables, which we had parsed, we had determined by doing comparisons between the selected icon data, between selected file datas. We actually do an equality comparison on each field between the first element and the second through nth. When we have a mixed field, I do a push item flag, mixed value true, and then pop afterward. And that's how you tell DRI and GUI that, hey, this field should be treated as a mixed field, which essentially contains the same value that it would otherwise. It just displays dashes instead. So let's look at that. I'm going to control click on combo, and that takes me to the combo box helper, and is value changed down here. Gives me the return result of this implementation function. Here we go. Which is interesting because it says it's an old API. I wonder if I should be using IMGUI combo. That's interesting. Let's take a look at the demo file. Actually, before I do that, I'm gonna actually confirm that there's not a listing for this inside of the demo. So this is the IMGUI widgets demo for combo boxes. So it just shows off how the combo boxes work, and you can look up the code for it. Oh, that's interesting. What's this mean? Only makes a difference if the pop-up is larger than the combo. Okay, I'm not really sure what that's about. But the no arrow button, no preview. That's interesting. No preview? Oh, that's kind of cool. I can, okay, whatever. That's all beside the point. Let's take a look at this code, the combo section. So that'll be in the demo. I'm searching for combo in quotes because that's how they do demo markers. Here we go. So widgets combo. This is the demo field. IMGUI tree node combo, right? Because it's an element of a tree. And then inside, IMGUI checkbox flags. So these are the options at the top. And then down here, Using the generic begin combo API, you have full control over how to display the combo contents. Your selection data could be an index, a pointer to the object, an ID for the object. Flag intrusively stored in the... Okay, that's interesting. So this is a different API than I am using currently. I was using ImGUI combo, which meant that I had to make the variable, that the backing variable, I had to make it an integer. But I guess you don't have to do that. So this is what I was using simplified one-liner combo API using values packed in a single constant string. This is a convenience for when the selection set is small and known at compile time. Yeah, that applies in my case because there's only so many kinds of texture types and minification filters. These are all fixed, and so they're known at compile time. Apparently, that's. I'm not sure if this comment is saying that this is actually more efficient, but it suggests, or not that comment, this comment, but it suggests that small selection sets known at compile time work better for this. That's my read of this. There we go. Simplified one-liner using an array of const char. This is not very useful, may be obsolete. Prefer begin combo and combo for full control. So in this case, they are passing in a dynamic. They're passing in a dynamic variable of const char. So items is not a string, literal like this, which is interesting. So maybe if I'm doing a dynamic set of items, then I guess I should be using begin and end. But yeah, I guess there's two APIs, and if I'm interpreting this correctly, the APIs have a different implementation. So I'll have to probably implement this multiple times. Huh. And what's this about the accessor function? Item getter, simplified one-liner combo using an accessor function. So the item getter is a function pointer that takes a pointer to data, an integer n, and then a void pointer. So this is probably like these two things are a data block, and then the out string. That's interesting. And the function itself basically just takes and returns, or it outputs using the output variable, a cast of data at n. Interesting. This probably doesn't apply to me. I don't think I really care about using it. But let's take a look at the begin and end combo implementations. I have a hunch that they work differently under the hood. It kind of looks like they do. So the begin combo actually features the implementation, it looks like. I was thinking that maybe it was like had like a wrapper and then there was other functions that feed into it, but no, this is just a begin combo box. So I guess to add support for both I'll need to add support for both the begin combo and the regular combo call, because the regular combo call, heading back to here, it has an implementation that is not utilized in begin combo, I don't think. Let me read. Old API prefer begin combo. Oh, okay, hey, here we go. Begin combo. So begin combo is actually used to fuel the old API too. That's interesting. So this old API business doesn't mean that it works so differently under the hood. It's just that it's this is preferred for more flexibility, I guess. But yeah, so if we change begin combo to support mixed fields, then all the combo boxes in ImGUI should follow. All right, so I'm gonna look through and find where we display the text. So the label is what we care about here. Okay. Window get ID label. So we get the ID from the label here. And then we calculate the size of the label using calc text size. Okay. And then we do a rectangle using the height of the label as a parameter. And W, where's W set? W is set from either calc item width or arrow size. And at this point, the current item is what? A frame, I guess. Though that's not immediately clear to me. I'm not seeing like an object being declared up above. I just see get frame height. Okay, well that's all right. Let's continue on looking for what we do with the label. Total bounding box is calculated as the greater of label size and 0. So these are floored at 0. Okay. Open on click, render shape, render preview, and label. Okay, so all this was about drawing the actual box, and then down here we have where we actually handle the label, and that's done with render text. We pass in all this business about the shape and spacing of everything, and then we pass in the label, which is used to do the label. Oh, you know, I'm focusing on the wrong thing. The label is what we put adjacent to the dropdown. I don't know why I got that confused in my head. So preview value is likely to be what we care about. So down here underneath custom preview, we're asserting that preview value equals null and so on. So I guess there's a way for you to override the preview from the use case. Enable begin combo preview. What does that do? I guess it's not exactly clear, but probably this is something to do with being able to override the default behavior of showing the value you selected. There's probably some edge cases that this was designed for, but it looks like in the case that we have a custom preview, we'll just ignore what was inside of preview value. And indeed, if you use a custom preview flag, there's an assertion that it must be null. All right, so down here, if preview value is not null and we are not, and the IAMGUI combo flags no preview has been set. Basically, they do a bitwise and this is a non-zero check, so it means that this bit's been set, or this flag has been set. Then we do render text clipped, and after that we say if the label size.x is greater than 0, then we will do render text. So I guess if it gets it'll choose between. I think I remember seeing code like this before when we were doing the mixed fields for the text box. It's like my read of this is that it'll try and draw it clipped inside of the bounds of the rectangle, and then if that's not enough, then it renders it again. I'm not really clear on what the difference is, but I guess it doesn't really matter, because when you do the render text with the preview value, that's where we need to have the correct thing. Hey Jolo, welcome in. Man, I feel so bad right now. Had to make a Smurf account to play with friends. That's fine. I'm sure your friends understood. Okay, so the goal here then is to take and set, when we have a mixed field, we'll have to set the preview value to be a string, like we have for mixed fields for the path where it says multiple values. But the poor enemy team, yep. Why did you have to make an account? Was there a rule against party size or something like that? My ranked rating is too high. Oh man. Oh, so they don't even they don't let you play with people of a certain rank, or they have to be in the same category as you. That's annoying. I guess I'm not really used to doing ranked things with friends online. A lot of times when I'm playing competitive with friends, it's not actually ranked. So I guess maybe more games do that than I suppose, but that seems like an alien concept to me. The idea that you would say, hey, if you want to play with your friends, you have to be that system has to match you together. That seems like, yeah. But yeah, if you're smurfing, other people are smurfing, and probably for more malicious reasons than I want to play with my friends. So I think you're in the clear. Only in competitive, yeah. Okay, I'm thinking about all the things I need to do to make this work. I need to make, first I have to set the preview value to be the mixed value string, or I have to supplant this call. I also have to worry about the return value. So if you select a new value, even if it's the same as the current value. So if I select these two items, if I was to click nearest, even though the field is already set to nearest, I want that to override this, and so it must return true, even though I haven't changed it. Okay. Yeah, so I guess what I'll do in here in preview value, I could just leave the preview value the same, and then I would just do a check inside of here, like if is mixed, then we would do something else. I want to play competitive with friends, but they're 11 ranks below me. Oh gosh. Total 25 ranks, that's crazy. Yeah, ranking in competitive games is, like, if you look at the history of ranking, it's actually a really stupid concept. Like so many games do it because like it feels good to rank up and do better. But like the ranking system that all these games use, everything from first person shooters to Hearthstone, they ripped it from chess tournaments, and it doesn't really it works for chess tournaments where it's one-on-one matches. Everybody is competing at with one person at a time, but it doesn't really work for anything else. But I don't know, somehow it's somehow everybody uses it. Like it's like like the ranking system that every game uses doesn't really apply unless you're doing one-on-one, because the whole point of it is that you're ranking against individuals, right, instead of teams. It's like, yeah, I don't know. I'm not super fond of ranking systems. They just kind of get in the way of having fun, in my opinion. Works really well, actually. Yeah, that's a matter of opinion, I suppose. What do you like about ranking systems? I'm gonna push a color here. Push style color. The color index will be the text color. And then we will set the color to be the color of the disabled color. So that would be ImGui get color, I think. And we're needing to get color in Vec4. What does it take? You can take either. Okay, so get color U32, and this will be ImGui. Okay, so we get the color index, and then yeah, so we'll set the ImGui color text index to be the value of text disabled. So it'll gray it out or do whatever your style settings suggests. Do I have to do another value? Index? No, I don't. Cool, so we'll do, if it's a mixed value, we'll push the disabled color, do the text, replacing preview value with multiple values, and then ImGui pop style color, like that. So this probably is good. I need to get the mixed value flag still, but I'll come back to that later. Now we have to worry about the begin combo pop-up return value. So if we return false, that means that we haven't made an edit. So as a reminder, in the ImGui calls, you'll get a return value of true if the value has changed. So that way, if you click a button, it returns true, and you know that I gotta respond to this button on this frame. If it's a text box, then it'll return true when you've edited the text, etc. So we have to change that behavior a little bit, because like I mentioned before, if I select the same field or same field value as the mixed field already contains, even though it says mixed values when you have multiple selected, I need it to still report a change. So we have some early out return falses. Hey Owen, welcome. Hi there, 1600 lines of code on that file is a little brain freeze. Yeah, this is actually an extremely long file. To be clear, right now I'm not working on my code. I'm working on the ImGui code real quick, because I want to implement mixed fields for the drop downs, so that way it'll actually look like we've got a multiple selection on those fields when we get to serializing. And this is almost done actually. This is going to be the easy part of today. But yeah, the way that ImGui's code is laid out is that all of the widget implementations, all of them for all of the widgets, and then like look at how many widgets there are. There's so many widgets. All of them are inside of this one CPP file. So we are in the top quarter section of the file and already at line 1614. So yeah, I don't think that's necessarily a good way to lay out your code. But thankfully it's not my code, so I don't have to bear the blame for it. Yes, so it looks like every return in this function up until the very last line is just an early out where we return false. So we'll need to edit the return value of begin combo pop-up, which is the very next function. So this is going to be the widget that appears when you click on the box and the little list appears. That makes sense. So we return false if ImGui pop-up flags is none, and okay, that's an early out, it looks like. I'm gonna, inside of this block, I'm gonna search for return. So I'm gonna do my little trick of collapsing the function, narrowing my search to the bounds, and then I'll search for return. There's only 3 return lines, it looks like. There's the early out at the beginning, then there's return false at the very, very end, and return true. IAM assert 0. This should never happen as we tested for is pop-up open above. So this is also a assertion situation. They probably just put return false. So for the sake of preventing a crash when assertions are disabled. So in release builds, if you ever encounter the situation, and for the sake of having every path return a value. But that's not quite true because we have a return true following right after that. Anyway, so it looks like the very, very end. Essentially, we only return true on this if we survive the earlier returns. That's strange, isn't it? Because it suggests that if you return begin name, it suggests that if you don't do anything, then it'll return true. But that can't be correct, because the whole point is that you select the thing and then the field returns true. Because the return value is defined by what you get out of this. Oh, I know what I'm missing. Okay, what I'm missing is that this is not the end of the code for the pop-up, because we do begin and then we close it off with end. So begin is where we would do the message multiple values, but probably end pop-up or end begin combo is where we do the return value for whether a change was made. This returns true if the widget is going to display. So that okay, I'm following. It's slowly but surely getting there. So we have end combo, and end combo literally just calls in pop-up. That's interesting. So let's take a look at end pop-up. End pop-up. Yeah. End pop-up returns void. Okay, so I'm not understanding this API, I guess. Let's take a look at how that works again. So begin combo, then we iterate through the items, so the things that we plug into the combo, and then we make a selectable inside of the combo box. Interesting. Oh, okay, so I get it. So you have full control over how you display the combo contents. So this basically just gives you a little field within which that you can display whatever you want. So if you want, you can do a combo. I wonder if they have something like that. I guess not. They don't really demonstrate this feature of combo boxes, but it kind of looks like you could just put whatever you want in there. You can do selectables, sure, but you could also do pictures. You could do other widgets. Basically, it's like you have with the right-click menu. You get a little window within which you can put whatever you want. Okay, so I think I'm following. But where does it determine GUI selectable is selected? Current item index. If is selected, IMGUI set item default focus. Set the initial focus when opening the combo. It is selected is set to whether the index in items is equal to n. The current item index is... Yeah, I'm not a huge fan of the begin combo API, but this is the implementation of how begin combo and end is used as part of the regular IMGUI combo box. So yeah, so this is the code for this field specifically. So when you go to select the selectable, it returns is selected, where it populates is selected, which is already true if the item index equals n. Okay, that makes sense. So the process of, okay, if I'm following this correctly, the process of determining whether the selection has changed, it has nothing to do with the begin combo API. That's something that you do outside of it. So inside of the begin combo function, then, all I do is I display multiple values if and when there are multiple values, or if and when the flag for mixed value is checked. And if it is, then that's good. Then that will display correctly. And the behavior when you go to select an item will have to be done either when you directly use the begin combo API, or when inside of the regular combo IMGUI combo function. Okay, so I think I'm following. If this is the case, if I'm following all this correctly, I just need to wrap up the whole if is mixed value thing, and then hop into the IMGUI combo function to do the rest. So I have to quickly double check how we did this. So we got the mixed value flag from g.lastItemData.inFlags. I'll just copy this whole thing. And then we'll go back to begin combo. And here it is. And where we were doing the mixed value business before, pool mixed value equals g.lastItemData. It looks like we already have this function already has loaded the IMGUI context. It was the first line up top, so I can just get the value directly without having to write any additional lines of code. So we're taking the last item data in flags, and we're setting the IMGUI item flags. We're checking for non-zero when we bitwise and the mixed value flag. All right. So that's looking good. I'm gonna go ahead and stop debugging and hit save and rerun, because already it should be displaying the mixed value text. Let me try that out. There we go. All right, so here's one selected, here's two selected. Perfect. So it says multiple values inside of the box now. And when I go to make a change, it does detect the change. However, oh, that's interesting. So it is also detecting the change when I select the field that it's already set to. So remember that these are read-only right now. The inspector doesn't actually change the files. That's the next thing we'll implement. So whenever I make a change up here, it's actually just changing what the inspector displays, not what the file contains. So this one's got linear, linear, linear. This one's got nearest, nearest, nearest. Because this field comes first, if I select the two of them, because it's looping through these icons in the order that they're displayed. This field, even though it says multiple values, does contain the value nearest. So if I click it, you see that it's currently listed as selected. I could probably get rid of that, actually. That's probably something I'll need to change. But if I click nearest, it still does return true and sets the value. So I think that means that one of the tasks that I thought I needed to do is a non-issue. As it is, we set the mixed flag to be false if the combo box returns true. So it's returning true when I selected nearest, even though it was already set to that. Cool. That's a funny behavior. Multiple files have their own values. Yeah. That's true. Yeah, the whole point though is that, like, if you have like files selected, then you can, and you wanted to change multiple at once. Like if you had like a bunch of skyboxes that were skybox assets, and you selected them, and they were all set to cube or whatever, then you could change their mipmap modes all simultaneously if you wanted. Though there's not a lot of reason to do with skyboxes. Skyboxes wasn't a bad example. Environment maps would be a better example, because skyboxes are you're not mapping those ever, probably, because they when you do a skybox, you're getting a one-to-one texel lookup for each texture. You're not really going to be shrinking that too often with your field of view. But in an environment map, the map levels will get smaller as you zoom out of the object that's reflecting the environment. But yeah, the idea is that I can just go in and set this for the files I have selected. And that's the way that Unity works too, which is what I'm basing this off of. Okay, so the one thing left then, before we move on, is this selection bit. Currently it does list nearest as the selected item, and if we have a multiple fields combo, it doesn't make sense for it to tell me that one of the fields is a particular value. It makes sense for text fields to display the previous first value, and it makes sense for, if we go back to a scene, I'll load up a scene real quick. It makes sense that if we select multiple drag floats, that it has a default value, so that way when I go to click and drag, they all align automatically. But it doesn't really make sense to do combo boxes that way. So because the selected item is determined by not the begin combo API, but the IamGUI combo function, which wraps it, we'll have to modify that real quick. And then we'll move on. So that'll be IamGUI combo. Here we go. And when we use it, we do begin combo, label, preview value, IamGUI, combo flags none, and then we display the items. So this is where the loop comes in. We iterate through all the items in the items in the combo box. We push an ID for its index to make all of the selections unique. And then we do item text. If items getter, so if we're using an items getter function, and it returns a null pointer, that's interesting. But where do we? Because the items getter is optional. Oh, there's more than one of these. Okay. So there's actually multiple implementations. Right. Okay. I'm following. Barely. Alright, so IamGUI combo. It takes the constchar array, and then hang on. Okay, oh, there's three. Okay, I'm following now. So this is the one that we are using, I believe. The label, the pointer to the current item index, the string with the all the items separated by 0 characters. Technically not null termination characters, I don't think, because we have to. Oh no, we pass in the length of it. So yeah, so null termination character separation, and then we do height and items. Okay. And so we do the call to combo, and so does this. Okay, so we just have to make changes to this function. When we do the call from this bottom function, we do actually have a getter function that's automatically passed in. So we're not getting around having a getter. It's just that it is wrapped in that helper function. So now that I'm following that, we are iterating through all the items. Is item selected equals I equals the dereference of current item. Current item is passed into the combo box. So what we'll need to do then, we'll need to set this to false always. when we have a multi-selection. If selectable, it'll indicate that it's selected already using the item selected business, where we pass in the Boolean. Yeah, so we just need to make this true. So what I could do is I could just do this as a ternary operation. I wonder how well that will go. So let's get the mixed value variable. It looks like we have access to the IMGUI context already, so I can just do the same copy and paste the global.item, last item data flags. And then on item selected, I could say mixed value question mark. And if it's mixed, then we'll say false always. Else, we will say the selection that we had before. And believe it or not, I think that's literally it. This is a relatively simple change, even though going in I didn't really have any idea how the combo box was implemented. It's just that IMGUI is that readable, that flexible. And so now if we do multi-selection on the textures, and then I click the drop down, nothing is selected. Okay, so this is working pretty good. I wonder though whether I like the idea of having multiple values in parentheses. I think it makes sense when you're dealing with multiple string fields, because the idea is that this is supposed to be a string field, but I'm thinking cosmetically it might make more sense for this to be dashes, kind of like what we have when we do the when we multi-select these mixed fields. We have a single hyphen. That might be a little bit better. Let's try that out, and then we'll move on. Okay, so that's down here. So inside of the begin combo, instead of doing multiple values in quotes, we would do a dash. And that also saves me the trouble of having to come back in and make this localizable later. Because a single dash is probably universal, or probably nearly universal, language-wise. And if we select multiple of these fields now, yeah, we got a little dash instead of having the multiple values. And I think that's, I don't know, I have mixed feelings about it. I feel like it should be actually a long dash, like the Unicode character long dash. But I'm going to refrain from doing that because that would probably something that we'd want to have when we're modifying the Dear IMGUI API. I don't really want to start like implementing custom stuff where I don't have to. And I want my code to be something that I can like put on the Dear IMGUI GitHub as a pull request. I think that probably the dashes I'll want to make that localizable as well. So maybe like defaults to a single dash, but if you want, you can have it display anything that you want when it's mixed. And then in my editor code, I would then pick the UTF character, or the Unicode character long dash instead, and that would make it look a little nicer. But yeah, for now I think that's good. I think we've got mixed fields going. The next task then is to get these written to file. So when I go to make a change, we click apply, and then it actually saves it to the YAML file. And that's probably going to be the bulk of today's stream. Doing good. Let's close out of the IMGUI stuff. We'll go back to textures.cpp while we're doing the implementation. And then we will go back to the inspector function. So let's quickly go over how this works. So we've got a bunch of static data here. And I'm not actually a fan of this. I did some experiments over the weekend regarding how to best implement inspector GUI callbacks. And I think I've decided that I'm going to encapsulate these into classes. This is a use case where classes really does come in handy. It'll be like a state pattern. So instead of registering a callback that does all of this, you'll create a class and register that class with the inspector, and then the class can have its own data store that isn't global, that's persistent only as long as you have that you're using that inspector, and then we can do some memory management stuff that will make that work really efficiently. And I've got a plan for that, but I'm not going to deal with that right now. So right now these are static, but in the future these are going to be member variables of a class. We'll just have to pretend like that's the way that it is right now. So these represent the internal state of the inspector, even though they're static and global right now. So we have the type field, paths field, min filter field, and all these different field variables. These represent the current value in the field in the inspector. So they have a bunch of defaults, but basically this is the value that will display in the inspector, unless it's mixed. However, we're not just storing these for the sake of tracking what the inspector displays. We are also using this as a point of comparison when the selection changes and we need to recalculate everything. So this will probably be handled in a separate call in the future, but for right now, we have a Boolean that'll tell us whether the selection has changed to this frame. And so the idea is that if you changed which files you selected inside of the content browser, we will then populate these field variables with the contents of the first of those files, and then we will use that as a point of comparison and check whether the values in all of the rest of the selected files match. So that's where this happens. So we have we initialize the is mixed variables, which tracks whether or not the fields are mixed, and then I also have a paths field.clear, and I memset the path buffer. Path buffer is a hack. I just have that here right now so that I can pass it into the regular text input without having to do conversions on the stream view all the time. But this is basically a replacement for this. We're just not really implementing it quite yet. And then we read the source file into YAML. And then we call this helper function parse texture metadata, and that uses RapidYAML to create a tree, and it goes through and it identifies all of the things we care about, and it returns true if everything loaded successfully, false if it didn't. If it doesn't, then we will say, hey, we have an error, and then we flag it, so that way inside of the inspector we can put a little message that says, hey, the at least one of the files you've selected doesn't work. It didn't load correctly. Otherwise, we have all of the field values populated from the contents of that value, or from that file. And at that point, we will. I have this little else block that's also part of my hack of doing one string for the path entry right now. But basically, if the thing loads successfully, then what I do is I do a mem copy from the first paths that we had loaded, which is a string view to remind you, a string view into the YAML buffer, and then we take and we will copy that into a regular C style character array, which gets passed into dir imGui later. But that'll disappear once we've got a better widget for the paths. All right, and then at the very end we have an error check, because if is_error is true, then that means that when we last changed our selection, we identified there was a problem, and then we just display the error message instead of doing all the rest. And what is all the rest? All the rest is that we compare against all the rest of the files. So we do another loop through the selected files. We do skip the first instance because remember we already loaded that file and we put it into the field variables. And then we do the same thing. We get another buffer. This is separate from the first buffer because I want to be using string views into the first buffer to represent the paths instead of having to allocate new ones. And then we do a stack allocated comparison value for each of these. So we do comparison values parsed in from the second through nth files, and then we check to see whether or not it differs from the first. So first we check to see is this field already reported as mixed. If it's not, meaning that we currently think that it's possible that the field matches across all the files, then we will do a check to see whether or not the compared field matches the first field. And if it does, then, or if it doesn't, then we set it to be, this inequality would turn out to be false, and then isMix would be set to true because this expression that doesn't equal that would equal true. Cool, so at this point we know whether the fields are mixed. We have a value for each of the fields. And then this is what we do every frame. We will display the error message if we had an issue loading one of the files. And if we didn't, then we do the combo boxes that we just set up to be mixed. Okay, and so this is where it gets a little complicated because I'm going to need to have like an apply button and a reset button. I'm launching Unity and Unreal again, and I'll be probably only focusing on the Unity aspect of this. Because Unity is the one that actually does an inspector for the assets, whereas in Unreal you have to double click on the asset and then you can make changes in a full-on editor, which is it works, but it's a different style. I guess we'll have to wait 10 years for Unity to launch, but when it pops up, I'm going to take a look at how it arranged things. For now, I'm going to have to add buttons somewhere. I think I'll do them on the top. So before we do the type box and before we do the all the other drop-down boxes, well, long-term, we're going to have a header that will do this for us. But for right now, we're just going to hack it together. We'll do imGui, button, and then give it a label. This will be apply, and then a size, which we will give 0, so it'll be the same size as the text allows. Hey Joel, welcome back. Played around. So you asked me why ELO is a good idea. Yeah, why is ranking a good idea? And I'll do same line, which is basically just to call it to say that the next thing I do is going to be following this on the same line, and we'll add another button. That's it. That's imGui. I guess reset or revert is the word I'm looking for. Like that. And then I need to get these to do something. but first I'm going to do a separator and just confirm that it looks right. F5. And Unity is still launching. In a competitive 5v5 shooter, in competitive 5v5 shooter games, it's a good idea because you wouldn't want people that are a lot worse to be in your competitive games. Yeah, but I mean, it's not. You're not being ranked as a team. You're being ranked as an individual, right? Like, to be clear, I'm not saying that it doesn't apply anywhere. It applies in 1v1 games of a specific kind. So specifically, it works well in the chess style ranking was designed for 1 versus 1 games where everybody has exactly the same playing field, same tools, everything. So like Hearthstone is 1v1, but the system I don't think applies to that game because Hearthstone you build decks that may or may not be able to take on every other deck. Whereas in chess, you all have the same pieces when you start. Yeah, the games take into account how good you did against specific people. Okay, that's interesting. Which game are we talking about, by the way? Are we talking about Counter-Strike or something else? Valorant, right? Is Valorant do like? So you got classes in there, but do you have like custom loadouts or things like that, where you like unlock guns and then you can use that in your multiplayer? Okay, there we go. We got an apply button and a revert button, which is good. We just need to make them do things. So I'll do bool is apply equals that, and then we'll do bool. But we don't actually need to track is apply or is revert. We can just do the revert. But is apply we will be using that. Oh, I didn't even think about that. So in a frame where you click on the apply button, you are not doing anything else that frame, I suppose, because you're not dragging and dropping something. You're not double clicking on a combo box or something like that. So you know what? I can just I don't have to store that either. I can just do if. Nope. Only agents that are categorized into 4 classes. They don't react to play a specific class. You still have 5 people play the same class. Okay, yeah, that's pretty cool. And having a small amount of classes helps make sure that everything is well balanced. However, like when you do like MLG style like tournaments and stuff, like those players are those players in those tournaments, they're ranked as a team, right? Not as individuals. So like in your case, you weren't able to play on your first account because your ranking as an individual was so much higher than the ranking of the rest of your team. As opposed to having your team be ranked as a unit. I'm trying to think about how to implement this. So in the case when we use revert. Ooh. Revert. Is Unity loaded? That's good. Let's take a look at how this typically works. I'm actually quite fond of the way that Unity handles the asset inspector, so I'm using it as a model. It's got a revert and apply button. Basically, they're grayed out if you haven't made any changes. If you make a change, like I changed these all to cursor types for some reason, they stop being grayed out, and I can either save this change to these selected files, or I can revert and undo it. However, that means that I have to track not just what the field says, but what the field used to say. So I'll have to do more states. Yeah, teams are obviously ranked themselves. Currently, those teams play custom games, and you have to be invited or asked to be in such a team. It's really hard to get into a team if you have no clout. Oh, I see. Yeah. Okay. Yeah, and I'll have to play Valorant to know like how it does things. Obviously, there's going to be exceptions to every rule, but in general, I found that the chess style ranking doesn't play well with a lot of first-person shooters. But maybe I'll try out Valorant and disagree after I've played it a bunch. Okay, but yeah, back on track. So with the revert and apply buttons, I'm going to have to. I like from a UX perspective, I prefer to have apply and revert up the top, and it also makes it possible for me to make this as part of the inspector code and not part of the custom file inspector code. So that way I can make this universal for all inspector types. The thing that I'm not liking is that this means that I'm going to have to make yet more static variables. And that's just kind of digging myself further into a hole that I was planning on crawling out of anyway. Okay, I'm actually going to reorder what I was going to do. The order of operations that I was going to do is I was going to finish the inspector and then put it into a better API that actually encapsulates it into a class. I think for the sake of my sanity, I'm going to do that first because it'll make it easier to track where the data's going. It'll also allow me to take all this code and move it outside of this CPP file, which will be great. Let me move my mic a little bit. i.e., CSGO's ranking system is pretty similar, but Valorant takes more things into account, such as the average KDA, average damage, and average... I'm not sure what ECO means. Exonomy? Or economy? Yeah, okay. That's a nice stat to track. I don't think like economy, like as in like how many kills per bullet or something. Like how efficient you were. Okay, I'm gonna put a pin in this code that I'm working on right here. How much damage per money spent? Oh, okay, yeah. Nice. Oh, money. Yeah, that's okay. Yeah. I'll have to try it out, and then we can have more intelligent conversations about Valorant. All right, I'm gonna quickly change gears, and I'm going to take a look at something that I've been working on the weekend. So I was thinking about this problem of state for inspectors. The big thing that I didn't quite like about doing just registering a function was that the inspectors themselves needed to have state associated with them, and you could have a bunch of different kinds of inspectors. So that would mean for every inspector that you've registered, all of them would have static variables associated with them, and they would all be in memory, even if you were using that inspector very rarely. And I think it kind of makes more sense that we do this one in a class. And I tend to not do classes in a lot of places that people would. Like, my systems are literally just free function calls because I'm like, let's not do it. Let's not have the developer have to instantiate an object of something just so that you can call functions on it. If it's global, just make it a global function. However, I do believe in classes when it comes to instantiating data to create objects, and the data, if it's just plain old data, I use a struct and I don't put too many functions in it, or I try not to put any functions inside of structs. But if you're doing operations on it, then it makes sense to have a class. So I use classes for my global state machine, for example. And classes are like the way that you do the state pattern for the most part. This matches the state pattern quite well. So the idea is that when you go to select files of a specific kind, the editor can say, hey, do I have an inspector type register for this? It can then allocate and display and operate and use it as a state inside of the inspector. All we need to do is encapsulate it. And that's a problem that I was working on this weekend, because the one problem that I don't like about the state pattern is that it involves allocation. You have to allocate the memory for the class. So that's not a huge deal for like global gameplay states, because you're doing that so rarely. Like if I load up a scene and hit play, so this is the scene we've been looking at forever now. If I hit the game tab and I click play, and now that we've got the game code executing, like this whole thing, the where it, I'm gonna plug in my Xbox controller now. This whole thing where it displays the scene and it has the gray background and it displays the level and I can control it with my gamepad or my mouse and keyboard. That whole thing is one state, and you would be very rarely creating a bunch of new states on top. That's not the case with the inspector when you're selecting multiple kinds of files, because this whole thing gets swapped out for a different kind of inspector each time you select a file, and you could be doing that a lot depending on your workflow. So I was thinking about how best to handle this. How do you make a state that's polymorphic, a polymorphic class that doesn't require the memory overhead of replacing it all the time? And I came up with this idea of just making it making a template type that manages this for you. So this is actually pretty well done at this point. I spent my Saturday working on this problem and testing it out. I've got a template class here that I can probably just copy and paste into my engine now, called PolyUnion. And the concept is this. Let me go to the testing code. So this is, I've got some tests running here. But the idea is that you, when you have like a class, like a base class, that you want to make a variable that can hold any of its children in, without having to worry about reallocations all the time from calling the new keyword to create a new object and then move that pointer into the pointer to the base class. You would just do a polyunion. So it would be like this, polyunion. And then the type that you provide is the base class. So in this example, I've got a file inspector base class, and then just give it a name, and this will be the inspector field. Yes, use Cling format, please. Valorant calculates ECO points like this: money spent divided by damage times 10. That's cool. Yeah, that's a useful statistic. That's like coming up with those values and doing intelligent things with them. That's the thing that I feel like I would suck at in game development. But thankfully, I haven't had to do that yet. Anyway, so here's how a polyunion works. This is essentially under the hood. It's just a pointer. I can pre-allocate a buffer by passing in a number like this. So by doing this, I'm allocating an arena of 1 kilobyte of memory that can be used to house objects of base type file inspector. And then I can do stuff like this: inspector field arrow, and then I can call the functions and members of the base type, and whatever object is inside it will operate on those. And I've got some helper stuff in here as well. Like I can do as and then cast to a custom inspector type like that. And then from then on, I've got the child class, and I can call the members of it. But most of the time, the idea is that you would be just doing the arrow and then accessing the file inspector base class stuff. And so the way that this would be useful would be like the inside of my editor code, I just have a polyunion of file inspectors. And then every time I do a reselection, I can just do inspector field dot in place, and then give it a type that is of the correct type. So custom inspector, B or whatever, and then pass in the things that needs to initialize it, and then all of a sudden, without having to get a bunch of new memory, I just use the arena that's inside of this variable. I just swap in a new inspector type. And then the rest of this project, the whole rest of this has to do with how I'm going to implement that. I've come up with a way to do a registration call that's actually really quite simple. Basically, inside of your editor code, you would say register file inspector. You pass in the template parameter is the type of the of the custom inspector that you want, and then you pass in the extension that you want to associate it with. And then under the hood, this function will it'll assert that it's the right type, but then it'll register a factory that can create that object with the inspector window. So that way, when you say load inspector, you pass in the extension, it will just look for the factory and call it. And then you've got an inspector that you can use. Cool. So I like this quite a lot. I'm going to go ahead and just do it now instead of later. Where is the polyunion? This whole thing, I can probably just copy and paste the whole thing. So we'll do that first. We'll go into here. Correction MS divided by damage times 10 divided by RP. Yeah, big old complicated algorithms involved in making that stuff work. You know, it's a really interesting example of this is the whole play of the game business, which, you know, a whole bunch of games started doing after Overwatch came up with it. But like Overwatch's killer feature was the play of the game. Like getting play of the game was like it was like the cherry on top of a match if you got play of the game, and then everybody got to see how cool you were in an epic moment. And that's an interesting one because like they track so many statistics about how the game went, from style moments to like epic killing sprees and things like that. Yeah. Overwatch 2 is the same, 30,000 Q. Yeah. All right, getting back on track. So I made polyunion to be very general use case, so I'm going to put that inside of the core tech, I think. So inside of the engine layer, inside of the include enterprise, and inside of core. Probably I'll put this in miscellaneous. Let me think about this. I could do this as its own header and like do like its own thing. This is the poly type doesn't have an implementation file. It's just a template. So what I could do. I think I'll put it inside of the miscellaneous. Miscellaneous presently has just a couple of macros, debug break for portably pausing the debugger, and then the stack allocation. So yeah, have fun, Jolo. Thanks for being here. I'll have to change the stream elements messages for for lurking. When I first set it up, I was just doing a whole bunch of jokes. I just fit in as many jokes of what you could be doing instead of watching. Like now you're chasing your refrigerator. I'll have to change that to something more sensible. But anyway, I could just do the type in here. You know what? I'm not going to do that. I'm going to do an actual bona fide header for this. So this will be polyunion.h. And then I'll just paste it in here. And if you want to use a polyunion in your code, you can just include engine core, whatever. It's just a little helper that I'll be using in my code. And if you have a use for it, and like if you just need a cheap state machine, then you could use it as well. Okay, so polyunion. I probably should put this inside of the EP namespace, just so that I'm not polluting the global namespace. But I won't put it in a nested namespace. It'll just be EP polyunion. So namespace EP, like so, and then I will save it, and then we will add it to CMake lists. We add the headers to the CMake lists because CMake Tools presumably uses it, but we also use the lists for when we go to install the editor. We need to get a copy of all the headers, so we maintain the lists inside of here to make that happen. So underneath core, this is sorted alphabetically. LMOP, so. That would be here then. So make this big. Make this bring in the include stuff, and we do all of this because, like I mentioned, we actually have to make this list work in other CMake list files. So I do a full path to the file, and this will be polyunion.h. I wonder, like, if I should do like something like that to make it like a C type or C++ header, but yeah, I'll do the capitalization like I do for my own types. Good, save, and that'll automatically trigger the configuration. Good, and then in polyunion.h, there's a few things we'll need to do to make this better. The way that we do allocation, if we take a look at the allocate arena call, allocation is done with aligned malloc, and there's an STD version of this. There's a C++ 11, I think, a C++ 11 call that does this, but for whatever reason, Microsoft doesn't want to implement that. They said that it conflicts with some of their low-level code, and so instead of just fixing it and implementing the feature, they just made their own with blackjack and hookers. So it's C++ aligned malloc, or aligned alloc is what it's called. And here it's aligned malloc, but it's aligned alloc in the standard. So in this case, we'll have to say we'll have to do an if-def on the malloc.h. Because malloc.h is malloc.h is C standard, isn't it? Or isn't it? No, it's a non-standard header. Yeah, so what we'll have to do is we'll have to if-def on Windows. So it'd be if-def Win32, and then else and endif. And because this is platform-specific stuff, I will be putting it down below. And So the let me think about this. The other header is standard though, stdlib.h. So I could just do an include for stdlib.h up here, like that, and then optionally include this. But I don't use stdlib for anything else, so maybe I should be putting that inside of the else statement. I'll put it inside the else statement down here. Hey Olan, yes I am still at it. What am I doing with alloc and malloc? I'm implementing a type that I came up with over the weekend. So I'm not going to go over all of it again, but I was thinking about the problem of cheap disposable state machines, which if we consider what the custom inspectors are, this is a disposable state machine that we only use when we have the EP texture file loaded up, and not when we have PNGs loaded up. I can't really just do function callbacks for this because each inspector type has its own state. So I wanted to encapsulate them in classes, but I didn't want to have to do allocations on the heap every time. So over the weekend I came up with this this crafty way to simply make a type that will serve as a union for every child class of a particular provided class. So I pass in the parent class to the constructor when I go to make the the parent class into the template when I make the type, and then all of a sudden that variable can be used to house any of its children, and it uses an arena allocation to make sure that we're not allocating on the heap every time. We can pre-reserve a size for the arena, so that way we say give me 1k, and then like in the edge case that we have an inspector that goes bigger than that, then it will reallocate the arena so to match that size, and then continue to use the arena to house single values of the object. And that's just a way to make it a little bit easier for me to make quick disposable state machines, but it'll also make it easier for me to do an API where I register a type and then house just one instance of that type. So yeah, we're playing with malloc here, and there's a lot of little things that go under the hood for something like this. The most important of which is alignment. In order to make the classes that you might derive from the base class, in order to ensure that they align correctly, we actually do an alignment with we align the arena with the alignment of the type max align t. The idea is that your types shouldn't be aligned to stricter values than it. If they are, though, I've got an assertion to catch it. I love Visual Studio Community. I prefer it to Visual Studio Code. Visual Studio Community is nice, and I used this for a good long while on Enterprise, and I still use it for projects like this. I just want to whip something up real quick. This is I finally have been trying out 2022, and it's got some nice features to it. Like I love the partial compilations of translation units. It's great, which I don't have here, but I think I'm kind of still like for a cross-platform project like this, I think I prefer code. You can do things like have little pets in the too. Got some cat here. Throw a ball. Just gonna go get it. All right, but yeah, so we're implementing this polyunion type. However, I have to if up a few things because the arena allocation call, which is aligned malloc, is MSVC specific, and so we have to conditionalize the includes there. For aligned malloc, and then this would be for aligned alloc. Sound very similar. They do the same thing, just that Microsoft has their own version for some reason. And I can't, even though it's literally part of the standard, I'm not allowed to use it in C++. Where's the C++ documentation for it? Yeah. So on this one, we would be using cstdlib. technically either would work, I think. All right, so aligned alloc, and then we have to if-def the calls to aligned malloc and aligned free, and use the correct version of the call. So this is where we do the arena allocation. We'll wrap this inside of an if-def win32 call, and then else it for macOS, and on the macOS side, we take the arena is equal to aligned alloc, and then its calls are the alignment and the size. So they reverse the order for some reason. Yeah, size, alignment, size. That's, I don't know why they want to do their own thing, but basically we just do the align of max align t, and then size rounded up. Which basically, when you go to allocate the arena, we pass in the size of whatever it is we want to be able to fit there. Oftentimes that'll be the size of the class that you initially store, but you can also pre-reserve a certain size. We round it up to the nearest multiple of aligned max t to make sure that we have a multiple alignment of the block, which is particularly important for std aligned alloc, which I think I have to do the std on it. Do I? There's a lot of these where they actually will put it in the global namespace anyway. For now, I'll just put std aligned alloc because I can't test it on Windows. I have to test it on my Mac once I get it fixed. But yeah, so we do the arena allocation, and the std version of this requires that we have the size be the right block to be a multiple of the alignment, and that's a good idea anyway, so I just do that for both versions. And then we have to worry about the free call. So in deallocate arena, very simple, we just check to see whether arena is a valid pointer, and then if it is a valid pointer, we will call aligned free. That's a Windows specific thing, so we'll macro it and we'll wrap it in the if-def, and then else we will do, I believe it's also called align free. No, it's just regular free. Okay, so std free on that, which is also in cstd lib. And we call it on arena, like that. Like that. Okay. Quick Alt Shift F to make sure that it's formatted fine. And this should be portable to Mac and Linux now. Okay. So that's the first part of this, is that we have a type with which we can do a cheap, easily swappable state machine. And I think I'm going to use this for all kinds of things, which is why I bothered to make it a full-on type. I think I'm going to be using this for things like encoders, so that way when you go to register the code for converting a type into whatever binary blob will fit inside of the shipping games bundle, it will be able to we'll have I'm imagining a situation where we have threads doing this as a job system. Each thread has its own polyunion for the base type encoder or something like that, and then it can swap those out as needed to encode each next file, and that's great. I'm actually really proud of this. I might do it, do a little write-up or do a little video on this thing by itself. But anyway, that's part one. We have polyunions now, and now we're going to want to implement the better API for registering this stuff. So that's going to be in editor.h. This is where we do all of the registration for things like inspectors. we have component inspectors already. I'm not going to bother with that because register component inspector, that's a little trickier. Technically speaking, it doesn't have its own state. It doesn't need to, at least, because the state is going to be pulled from the entity component system every frame. But I might encapsulate that later. It just would require a refactor, and that's outside of the scope of what I want to do today. So what we're going to do is we're going to change. First, we're going to change this callback thing. We're going to probably just get rid of it, actually. And then the register file inspector call will look different. I'll just comment it out as well, and we can kind of start over, and I can use it as a point of reference if I need to. So obviously this is a API call, so I'm going to need to export it. So EP API, and then we'll say register file inspector, and then in this case we're going to be including we're going to make this templated. That's right. Actually, if we're templating this, I don't need the EP API because it's a template. The template will take a class type that we will call tBase. And then we will do return void. I don't think I need to do a return of any other type. And then we need to register the extension. So that's going to be a const std string reference extension. And that's it. It's actually a fairly simple call. When you go to use it, you pass in the type that you want the inspector to be. This will automatically create a factory for creating instances of your inspector inside of the polytype variable. And I'm going to be copying some code from here where I've done it already. Yeah. So where did we do the registry? So this is what I'm going to base my API off of. Yeah, we don't need to do a return value, so this is probably all going to be the same. We do need to have a assertion that it's of the correct base, so that is we need to, the whole point is that this accepts a file inspector type, so we have to have a base class to build it off of. And then we basically do an implementation call, the purpose of which is to do this outside of the scope of the header, so that this is all the implementation you see if you wanted to open up the header and inspect it yourself. So yeah, so reading through the code, we basically call the inspector implementation function, which is declared here. Its purpose is to associate the extension with a polyunion factory. So yeah, I'm just going to copy this whole thing. And then I can paste it right there. This isn't strictly speaking part of the API, but you can't, with templates, you can't avoid putting these in your headers. So I'm gonna make it pretty clear that these are things that you don't use in the API because you have underscores in front, and this one simply says implementation for this. You'll see both of these in IntelliSense, and you'll say, hey, this is the one that I'm supposed to use. This is what it wraps. Cool. And then we'll need to add a function call here. We'll need to make a few additions as well. So outside of editor, I'll need a header and CPP file for the inspector class type. I guess this would belong inside of the editor folder as well. So inside of engine include enterprise editor, we would have this header call. Let's do a new file. This will be file inspector.h. We'll do the whole business with, hang on a second. I just realized polyunion doesn't have a pragma once statement. It doesn't have a header guard. Let's put that in. And then in here, do the same thing, pragma once. And then we'll need to make a class type. I think I've actually did this too in here somewhere, file inspector.h. I don't know if I'll keep it the same way, but yeah, we've got const reference, instructor, our value reference constructor. I wonder why I have these declared. I don't remember doing that. It's possible that Visual Studio community automatically generated these for me. I do need a virtual destructor though. And init will be where we set up the state. That's just so that you can have a factory function create the state without having parameters inside of the constructor. Do I have? Let me take a look at the factory call. This is a templated factory. Basically, just adds the type of the. Basically, just adds the populates the inspector with an object of this type. Yeah, so this doesn't accept parameter calls. You could make the you could do something similar, something simple. So right now the factory simply receives a reference to the variable we're supposed to populate, which is a polyunion type. What I could do is do variadic arguments here, or a parameter pack. So it'd be like arg. I'd have to do another type of be like type name args, like that, and then it'd be args. I think that, except for I would have to do. I can't quite remember how you're supposed to do this, but it would be something like this. Or is it like this? There's a way to do a parameter type that's a parameter pack. I just don't do it all that often. But anyway, the idea is that you would have the constructor actually accept the variables that go into the constructor for the type and pass it in that way. I actually like that quite a lot. So we'll do that instead. But for starters, for the file inspector class type itself, we're basically just going to have an onInspector GUI, and we're going to have a virtual void onSelection updated, like that. So that way, whenever you change the selection, we don't even need to do that. That actually, man, I'm thinking this through as I go. We don't need to do a non-selection updated call. We just have the constructor handle the loading of the file data and parsing the file data. And then that way the editor will simply destroy the inspector and replace it with a new one using the arena so that it's fast. And so the constructor and destructor can be used to load and clean up the load of the files that it cares about. I think I've realized what the problem with that is. I need the inspector to know which files to load, which means that we can't. It means that we're going to have to specify these strings in either the init call or the constructor. Okay, yeah, so we're going to have a separate init call. All right, so without further ado, we'll do a class. This will be a file inspector. Let's put this in the enterprise namespace, though. Namespace. No, this would be in the editor namespace. This would be the category of things that you only put inside the editor. So we've got a class file inspector. It will have a virtual destructor. Which will also make it a pure virtual. Can we do that for destructors? No, I don't think we can. It has to be virtual though. Then we will do on inspector GUI, which will be a virtual void on inspector GUI. This will be the call that callback for when you need to render your widgets to the screen, and then we'll make that a pure virtual. We will need the executive decision time. In this demo, I just simply had an init call that's called after the object's created. I need a way for the object to know which files to load. But I can't do a virtual constructor. There's no such thing as a virtual constructor. You just have constructors that, when they're invoked, they can invoke the base constructor. That's probably why I used init, actually, now I'm thinking about it, instead of a constructor to do all this. So we'll have to do a virtual void init call. However, this one's going to take parameters. So we'll need to include string for the string type. And we'll need to include hang on. I'm looking for inspector.cmp selected files. Selected files is, yeah, it's a set of strings. So we'll need to use the same here. So include string, include set. And then we'll use a const std set of string reference, and this will be selected files. Right. Except for that's not how you spell const. So that's one way. Yeah, semicolon there. This also needs to be a pure virtual. So I guess it would make sense to also have a cleanup call. We could use the destructor to handle that. The main reason why I wouldn't use the constructor or destructor for these things is because you can't prescribe a child class use a specific format for the constructor or destructor. And also, sometimes you want to do things out of order. You want to initialize after construction for some reason. However, I like the idea of pairing init calls with cleanup calls. So yeah, I'll do a virtual void on the cleanup, and we'll use it instead. That's just, you could do it either way. Somebody who's making their own custom file inspector, they could either use cleanup or use the destructor, but I'm going to provide a cleanup. Actually, I'll do it as a pure virtual. I won't. I will leave it as a regular virtual. You can override it if you want to. And then you can either use cleanup or the destructor to clean up. This is just going to be a style choice, but the rest of it is required, and that's it. This is the class. I'll quickly write a quick description of it. No, I won't. I'll do the English stuff later. And then we'll need a CPP file, so we'll go into the source editor, and we'll add new file. And that new file is file inspector.cpp. Do we need that? No, we don't need that. We don't need a CPP file. We can just use this declaration to make a child. Let us say equals default. And is there a default on see, I don't want to make it pure virtual, because if I do, then you'll be required to implement it. But I'm actually not entirely sure whether or not I need to provide a definition for file inspector cleanup in a CPP file. I'll just leave it for now, and then if I'm forced to do an implementation, I'll add a CPP file then. But let's go to CMake lists now. Engine, we'll add this header. So that's going to be down here, the editor stuff. We will do below API and GUI. We'll do file inspector.h. Oh, it's got to be inside of the editor folder, like that. Cool. Save. That'll add it to the build system. There we go. Close out of that. I'm just going to kill Enterprise real quick. I don't really need it. Alright, and then we can use that to come up with the texture file inspector. So for that, this will actually not be in the editor layer. This will be inside the engine layer. So the editor stuff, in a second. I mean, inside of the editor include folder. The editor include stuff that's intended for use by your game API. While Enterprise does use that API for some things, like what we're about to do, its use of it will still be inside of the engine layer. I don't know if anything I'm saying makes any sense, but I'm thinking out loud here. So inside of the engine include and Enterprise, we will add this to the graphics section. We'll do a new file. This will be texture inspector.h. Do the same thing as before, pragma once. And then we'll do include oh, this should be inside of, this should be at a different location. This should not be inside of the Enterprise folder. This should be inside of the EP internal folder, because I don't want this to be exposed to game developers. So EP internal graphics. Okay. So here we'll do the include of Enterprise core editor file inspector, and now we got the ability to do file inspectors. We will put this inside of the Enterprise namespace. We'll actually put it inside of the graphics namespace, because this is for graphics, the graphics API. And then we will do a class definition. Texture inspector, so it extends public file inspector. Public editor file inspector, that's right. Like this. And now we've got a place to do this stuff. So we'll need to do an implementation for on inspector GUI. That was a void return type. We'll also need a void init where we take the set of strings for the files. So we'll do those includes here. Include set, include string. And this will take the const std set of std string by reference, and this will be selected files like that. And then we do need to have cleanup, I believe. Oh, I need a semicolon here. Oh, hang on. I need to pass this into init, not into onInspector GUI. Getting ahead of myself. All right, cool. So this will override that virtual function. I should say override on these. I'll just do a void cleanup here. I don't think that I really need cleanup for anything. I'm trying to think if I do. Virtually all the state that we're going to have inside of this inspector is going to be cleaned up automatically. Oh, I gotta make these public. And I gotta do the same thing for file inspector. I don't know why I missed that. Okay, save that. And then in here we have public as well. Yeah, I don't know if we'll need cleanup, but I'll put it in there just in case. And then we'll need the implementation file, which will be inside of the source. Source, graphics, new file, texture inspector.cpp. Now, as always, we include the main include up top, so that's going to be enterprise graphics, texture inspector, oh, it's not in my list yet. I'll add it. Oh, it's EP internal. That's why it's not in my list. Graphics, texture inspector.h. And then we can do the implementations for these functions there. Oop. That. And this will be texture, inspector, colon. We get rid of the override stuff. We add braces. And we need this in the correct namespace. All right. It's looking pretty good. Okay. Let's add these files to CMake lists. So this is the engine headers. In the protected headers, underneath textures.h, we will be adding texture inspector.h. And excuse me. Inside of the CPP files, underneath textures, we will be adding texture inspector.cpp. Cool. Control S, make the new build system, and that's done. All right. So now we have something in which to throw all of that state code. So let's head back to the CPP file. I'm going to put this on the left, and we'll work on the class on the right. And now we can start moving in things from the call that we don't need anymore. For starters, the parse texture metadata helper function, we can cut that whole thing out. this whole thing, Control X, and paste it into the CPP file up here. It's a helper function after all. The thing that we're wanting it to help is going to be inside of texture_inspector.cpp now. And then the onInspector GUI call will look a little different, but we're going to copy most of this out. So this stuff is going to go into init mostly. Well, these declarations are going to go into the class header, but the initialization code where we actually load up the file, so selection changed, everything in this block is going to go into the init call. Everything after that will go into the onInspector GUI. So I'm going to take and select it. All of this. Control exit. And onInspector GUI, it's down here. We will paste it here. Good. And then the texture implementation. Then we'll need to put all of these state variables inside of the header as private members of the class. Everything that's static belongs inside of the class, the new class we're making. And my style is to do public stuff and then private stuff, even though the default access for members of the class is private. A lot of people do private and then they do public when they want to go public. But I start with public stuff first because you're looking at the class, you want to see what it does, and that's the public stuff. We'll paste in all of these members. Yep, and they all belong here. Do we have any other statics that we need to care about? We do need to maintain a YAML buffer as a private member, but yeah, so I'll cut this out and put it inside of the header as well. The YAML, the purpose of the YAML buffer being stored inside of the being a member of the class is because we need that to persist for us to reference all of the text that's located in it, which might not be a lot of text, but we have to allocate a buffer for the YAML anyway. And instead of just allocating a new string for every single path we have in there, we can just use the string views that we get out of the Rapid YAML library and reference those. Okay, and I'm not seeing any more static keywords. So what we can do here is everything inside of the isSelectionChanged block now goes inside of the init call. Because the object is going to be constructed when we have a selection made. So inside of init here, I'll put all of that code from before. All right, and now we can get rid of the onInspector GUI static call completely. However, there are more helper functions we need to take out of here for use inside of the inspector. So tell to use textures. Yeah. So that includes the string to text filter, string to bitmap mode, string to texture filter type, and the projection conversion. Control X that. All right, and then at the top of this file, we will paste it. And then these are used inside of the parse column. All right. Awesome. Just reviewing where that puts the CPP file. Okay. So the parse texture metadata call actually does have a purpose inside of the texture header, but I need it inside of the CPP file as well, inside of the texture inspector CPP file. So we're gonna need to make this no longer a static. We'll need to make this a member of the internal textures header, so that way it's visible to the engine and the editor, but not visible to the game. And we'll move it. We'll include that header in both of these files. So let's go to textures.h, the internal one. And then above the load texture implementation section, we will do an EP API, bool parse texture metadata. And I'll just cut and paste this whole function description into here, this whole signature. All right. Good. So now we've got a helper function inside of the internal textures header. We'll put the definition. Let me look at this. We'll put the definition back in textures.cpp, but it's no longer a static. We'll save that. And then this is the load texture call. Set texture properties. So I think above the load texture implementation, I will paste this back in. Right, okay. Oh, but then it needs the string to texture type call as well. Okay. So some of these helper functions then, string to text filter, string to minute mode. These need to be available. Well, these need to be available for the parse texture function to begin with. So these can remain static, but they need to follow the parse call into the textures.cpp. Okay, this is making sense. Okay, so we got the OGL stuff, and then we got the parsing helpers, one of which is going to be used in multiple CPP files. Though now that I'm thinking about it, I don't see why I should export it. I'll export it if and when I go to use it inside of the editor. Okay, good. All right, I think we're we're close. Okay, got some red squiggles at the bottom down here. This red squiggle, it's actually just one, and it's the one that I knew about. We got rid of the old style of register file inspector, whereas before we were just registering a callback with the texture type. the new API, and I'll pull that up now. The new API is templated and it accepts this is the editor.h. And it accepts the class type as a parameter instead. So I'll leave that unresolved for the moment until we've got this class sorted out. But the rest of it looks fine. All right, so now we're back in texture inspector.cpp. What's the header complaining about? Okay, we need to bring in some types from textures now. So texture type, what is texture type? Texture type is a static. It's used. Yeah, it's used in the parsing section as well. So we're going to need to move this as well. Let me find that definition. It's an enum class inside of the EP internal header. And that's actually where it belongs. So in order to get that access to that stuff, we'll do an include for it'll be enterprise graphics textures.h. Except for it's not the public one, it's the EP internal one, the private one, or the protected one. That should resolve most of those little red squiggles. However, these are not static anymore. So what I'll do is I'll shift select, get rid of the static keyword. I'll have to reselect, I accidentally deselected. So inside of that block, anything that's static is now not. Okay, so these are now private member variables, which is good. So we are keeping the type field, we're keeping the paths field, which right now is we're not using all of them, we're just using the one. And these will be allocated and destroyed as we change modes in the inspector. All right. And this doesn't really feel very organized to me. I'm going to try a couple of different ways to do this. Associating each variable with its mixed flag. Does that look better? I don't know that it does. I'll put all the mixed fields, the mixed flags, in their own block. Type field. I'll separate these by kind. This will eventually be on its own, but for now I'll associate the path buffer with the paths field. These make sense together. Slice data, QMap projection, mix trackers, and then is in error. I'll make a quick little note about this, so I'm not confused about it later. For selected YAML files, YAML is kept to preserve path field or path strings, string references. Huh. Actually, not sure how I feel about that. when we go to parse out the data from the YAML file using parse texture metadata, we pass in the YAML as a string reference. We use parse in place, and we get a tree out of it, which we use to get everything else. The paths out comes out as as pointers, references into the buffer, because that's the way that RabbitYAML works. It doesn't allocate these strings all over again. And inside of the parsing, at least, we need to hold on to those string references. It makes sense for this helper function to return those references inside of the YAML buffer, and then you can deal with them without reallocating. But what I'm wondering about is whether, when we go to create the inspector, we actually need all that data, or whether we should just allocate strings for each of the values. So we do need to keep track of the values of at least one texture. You know what? I don't think we do. Now that I'm thinking this through, I think we could actually just, instead of doing a vector of string views into the original YAML buffer, and instead of storing the YAML buffer, we just, during initialization, we load the file into a temporary buffer and parse the data out of that. Then we just store, let me think about this. We just store the strings themselves into, this would be a regular vector of strings. Which, to be clear, this only represents a single texture, so or texture asset. So you select a texture asset. That asset can use multiple textures. This is an array of the strings that go into that. And I could probably do better than this and change this to be a regular character array. But for now, I'll do a vector of strings, and I'll worry about optimization later. Yeah, so this would involve a copy, but it would mean that we only have to store, that we have a single std string temporary holding the YAML file. So we don't have two YAML files loaded into memory at the same time. And then when we go to make edits, this will be a much easier to edit buffer, because we can make the edits to the buffer independently from the YAML buffer. Okay, I think this is following. So we're going to change the paths field to actually be a vector of strings, and this means that I'm going to get rid of the temporary hacky buffer that I've been using to actually display the widget, because I can always just do pass field dot first or dot front. Cool. So that's looking better. Let me do some comments. I'll say that this is the widget field vars mixed status tracking, and then I'm going to put the error value to the top. Bool is error equals false. Okay, it's looking good. And then the thing that brought me to that made me think I should change how I'm doing this before I continue is the fact that we need to have values to revert to. So these fields here represent what the widget has now, their display values. We need a copy of all of them that represents what we should revert to. We'll also need a copy of all of the mixed flags that indicates this as well. And that's really annoying. So one way that we could do this would be we could just literally make each of these things an array of size 2. And then the 0th element would be what the field is now, and then the 1 is the backup element. I think I like that quite a bit. This remember that this is something that will be hidden from game developers, so I don't really need the code to be super intuitive. I can just make this work for me and then put a comment to remind myself what I did. I think that probably works best for me. I think I like this the best. I'm gonna do it. And of course that means that I can't default initialize the way that I had been. I'm gonna put that node in real quick. Element 0 display value. And element 1 is the backup revert value. Okay. All right, cool. And then in this case, none is 0, linear is 1. Maybe I should default all these to 0. What's I guess nearest would be 0 in the case of. So no, I'll do the defaults the way that I had them. But in order to assign these, I do need to make the I do need to do a quick little array. So for these and this one, we will do a copy and then paste like that. And then for these, because these evaluate to 0, I will replace them all with 0 and braces, like that. Right? Is that not a problem? Value of type int. Oh, it's not I would have to cast it. I can't just do this and have it work. So I'll do it the other way. A little annoying, but probably I think this is still more elegant than doubling the number of lines for what we're dealing with. This though can be 0. Because it's a Boolean type in it, and that can be initialized to, yeah. All right, and this one, projection field. Oh, I didn't get the array tag on it. So both none and none, because these are enum classes, and you can't. I don't want to explicitly cast them for any reason. And then these will be defaulted to false. I can just do this for those. All right, cool. I think that's making some sense. Like that. All right, cool. Pretty clear and concise. All right, save that, and now this is all looking well and good. Let me resolve the last error in textures.cpp before moving on. And that last error was we need to change this API to actually take the correct type as a template parameter. So this will be texture inspector. And in order to get access to this type, we need to include the new header, which is texture inspector.h and the graphics. There we go. This is AP internal. So down on our new API call, the register file inspector takes the texture inspector type and registers this class with this extension. So that way, when we go to select a file type and the content browser, the inspector window determines that we've selected files of exclusively .eptext, it will say, I will create a texture inspector for them. And it'll do it in that arena allocation that we've got going on with the poly unions to make that really fast and easy to swap in and out. Okay, we still haven't actually implemented this call yet, which we'll have to do soon. But before I do that, I'm kind of on a roll with the texture inspector class, so we will wrap it up and then head back to getting the registration working correctly. Cool. So here we go. Now all of this is got to be modified now that we've changed how everything is laid out. So for starters, there's no path buff. We also don't have to do default initializations during init because this is only going to be called once at the time that we go to load up the inspector for this type. So the only responsibility of init then is to actually go and parse through and load up the textures. So, or the texture files. So from here, we'll need to add the file system. So we got enterprise file.h, that'll give us access to the file text file and error codes and things like that. And then we need the YAML buffer. YAML buffer is now going to be a local for the sake of initialization. We have taken that out of the private members. So we'll do an std string YAML buffer. And then we pass in, currently this API takes a reference instead of taking a pointer. You know, screw it, I'm going to change that right now. No, I'll do it later. I want to do it now, but I realize that I'll have to go and chase down all of the places where we use the function and fix that code. So I'll do it later. But anyway, it takes this and it's an out variable. So it'll populate YAML buffer with the contents of that file. If it's successful, then we can call parse texture metadata or whatever. And now all of these are complaining because these are now arrays. So we're going to be populating the display values first, and then we're going to memcopy to the backup value. Maybe I should do it the other way. I should do the backup value first and whatever. I don't know. I think it'll be easier this way. Technically, these are arrays. So I just pass in the name, and it'll give me the pointer to the 0th element. Paths field now doesn't take that. Paths field is not the same type. So we'll need to do a local for it as well. So we'll do std, what does it give us? It gives us a set of, come on, Oh, IntelliSense is being a jerk right now. Textures.h parse texture metadata. It gives us a vector of string views. And this will be the paths view. This is paths views. And we'll pass that address in here. And yeah, you know what? For all of these, I think I will do the address of the backup instead of the address of the first. So I will do +1 on all of these. So what this should do is this is a pointer of the type texture type, and if I add 1 to it, it'll increment the address up to the first element. So that's what I'm doing there. Cool. And then this will fill paths views, and it'll fill all of these other members with the values of the first file. And now I can get rid of this hack line, and the only thing that's not populated yet is paths views. Though I guess we should populate the first element as well. So we'll need to do a so what we'll do in the else block here is we'll do a mem copy for all of these arrays, and we'll do a direct copy. We'll do a mem copy from the paths views into the vector we've got going for the sake of the paths out. All right, I think that's doing good. I think we're on the right track. I'm gonna make this a little bit simpler and just do this, and we'll copy from the front instead of the back. There's not a lot of information on data-oriented design, it's sad. Yeah, data-oriented stuff, yeah. I feel like that's probably not correct. There's probably books and books on it. I haven't really looked into it though. Have you been looking for resources on data-oriented code and not finding any? I know that like the way that I learned about data-oriented stuff was like looking at blocks on game engine architecture. Like I don't even think, like I think the game engine architecture book by Jason Gregory, which I've got on the shelf over there, I think that covers some data-oriented stuff. Like it covers things like object pools and stuff like that. But there's one book, 2 to 3 vlog post, but it is not a document like OOP or, yeah, everybody really likes OOP. Fewer people, but plenty of people like functional programming. Data-oriented design is something that's like, I guess it's something that applies to both. So it's not really like, I don't know, like it's not like it flies in the face of object-oriented or functional. Functional programmers probably will care more about it because like the kinds of concerns that make a person think functionally, oftentimes that leads you to data-oriented stuff anyway, because it's about simplicity and making sure that everything is efficient. And in OOP, people are just used to allocating on the heap all the time, so they kind of extend that logic to how they handle data. But I mean, ask any game developer, at least any programmer that knows what they're doing in games, and even though they may be object-oriented, they'll still do object pools and things like that for data-oriented stuff. Yeah, I don't know. But yeah, it's I guess it is maybe difficult to find really good resources. I haven't really done a huge amount of research on it. I just kind of like got the gist of it and learned like the basic data structures that people use, for making sure that they're working in a data-oriented fashion, and I learned what makes something cache friendly, and then I just kind of filled in the blanks for myself. But anyway, now that we've got all these values, we're going to need to do those mem copies. So I will just Alt double click on each of these, get the names, and copy them and posted them, and then I'll do mem copy, and then I'll need to do these addresses. So mem copy for the address of each of you needs to be +1 for the destination, and then the origin needs to be the the first address, and then the size needs to be size of the type. So I'll need to do this separately for each of them. Like so. Let me get the size for the types out of the declaration here. So the types are going to be texture type, filter, copy, and then paste the types in here. Paste. Okay, so that should be all the arrays copied, right? What are you doing? Oh, it's complaining about the top line. Okay. And now, so for Pat says views, these are different types, technically speaking. We got a set of string views. Why is that a set? Do I need it to be a set? I think I wanted it to be a set because in the case that there was a duplicate line, a set is an easy way to dedupe. But oh no, it is a vector. Okay, never mind. So it does take a vector. So we got a vector of string views and a vector of strings. So that's easy enough. We'll need to do a loop though. So we'll do for because the structures are fundamentally different. So we'll need to do a loop for every string view. Reference in the paths views at 0. Yes. Right? Paths views. Hang on. Not paths views. Paths field at 0. Wait. I'm getting backwards. We're iterating through this vector of string views, and then we're copying that into paths field, which is a vector of strings. Okay, I got it backwards. So we're getting all the string views out of paths views, and we don't need an array member in it. And then here we'll do a mem copy. From, that would be sv.data, wait, from, double checking, yeah, to and then from, right. So that'd be, we're copying to, oh, we can't do a mem copy. What am I saying? We need to construct the string. So, yeah, so we're going through paths views. We need to do, paths field at 0 dot in place, and then we can pass in the data from the string view. I think we can actually pass in the string view itself, can't we? Can we construct a string from a string view? I'll double check. Implicitly converts T, so number 10. We can pass in a string view like class by reference. How about our value reference to, is there a move constructor? Oh wait, no, why would there be a move constructor? It has to be a copy instructor. Yeah, so apparently it takes a string view like. Oh, but I'm using in place, not pushback. Right. So I'm not constructing per se. I know I am constructing. What's wrong with this? This is a const string view reference. Take a look at number 10. Explicit basic string. Pass in a const reference to a string view like. And then you can pass in an allocator if you want. So what's number 10 say? Implicitly converts T into a string view. To a string view SV as if by basic string view car T, whatever. Then initializes the string with the contents of SV as if by Hey Devil, welcome in. Argument types are const std string view. Oh, it's coming in by value. I don't know if I'm a masochist, but I like trying to code in data-oriented design approach. Well, it's like trying to figure out a new way to code. Nice, yeah, it's good that you're having fun. The data-oriented design, I like it in the general case. There's probably cases where it will just make your code incomprehensible, but I like to think in terms of data-oriented design because it's like it's a perspective that directly relates to how the computer will actually use the data. And it makes sense for me to think in the terms that the computer does because it makes ultimately the computer is the thing that cares that you're writing code for. So no instance matches the argument list. Object type is std string. I don't know why this is giving me grief. Why wouldn't this just work? std string view like. Oh, here's some example code. Oh, it's not listing. So we got alpha, beta, for C++ 11. Okay, whatever. I just don't understand why it's not working, so I'm spending too much time thinking about it. So what we can do is we can do sv.data, sv.size, and then we can just move on. This should be doing a constructor from those two elements. Const star size t. Object type is. Oh my gosh, this was so stupid of me. The problem had nothing to do with the type. It had to do with the fact that I'm not accessing the vector yet. I have to do it in place back, and then it should work. Okay, there we go. Now it's not complaining. God. Okay. Yeah. So basically, I needed to do it in place back for that field. All right. So now we have to do. I guess I'll just do insertions here. Though I don't. Yeah. At the very end, I'll do a copy. I'll do paths field 1 dot reserve, except for there's only one S, dot reserve, side or paths field 0 dot size, and then we will do a copy. Actually, I could probably just do an assignment, can't I? Yolan TV, I didn't even know data-oriented design was a thing. Oh, I should read these faster before they disappear from my screen. Of course, I knew arrays and ways of using it that would be, in that sense, would not be data-oriented. I guess I programmed that way because it made more sense. Yeah, that's good. It makes logical sense. But yeah, I'm doing good. How about you, Devilwalks? Had a nice, relaxing weekend myself, and now I'm just eager to get this thing working. Okay. Cool. And then that should be, yeah. Because I think if you do a vector assignment to another vector, it just copies it. I'm always looking up the minutia of the standard library stuff. Where's your assignment operator? Const reference other. Copy assignment operator replaces the contents with a copy of the contents of other. Perfect. Sweet. So that's that. Now we have everything set up from the original file. We've reported an error here if there's an error. Cool. And then if there's been no error, then we will do the comparisons between the first file and all the rest of them. Not too bad. Sweet. I'm doing fine. Listening to my train of thought while reading technical blogs. Okay, here we go. So this is where we do the comparisons. We're in C++ 17, so I don't have the ability to do a range and just say like drop first or whatever it's called in C++ 20. So for now, I'm just kind of have this hacky thing where I say is first loop, and then we continue on the first loop. Sort of hacky, but I'd rather do this than use iterators here. All right, good. And then we have a compare buffer. We don't actually need the compare buffer anymore. We can now just use the same stack allocated YAML buffer, this guy, and compare against the stuff we got out from before. Cool. So we load up the YAML buffer. However, I think we do have to clear it. I might have fixed that over the outstring.clear, so it clears on its own. And then we can use YAML buffer instead of compare buffer for the parsing as well. Cool. We have comparison values for paths for type compare. In this case, we are going to use the string view for comparison's sake, because while we're parsing, we have the YAML buffer allocated, so we may as well use it. Good. That's all looking good. And then we have the comparison logic. The comparison logic should actually be pretty much the same, with the exception of paths. The one difference is that we are now using arrays, so we'll have to do an array element access here. Like this. Learned that argv is a thing, which is nice for terminal apps. Yep. The argv and argc, the old school way of doing program arguments. So all of the mixed fields. I don't know why I keep forgetting this. So the display value is 0. The 1 is the backup value. Okay. Right. Okay, so these will be set by these comparisons. The compare is a singular type, but these are array types, because we have the display value and then the backup value for reversion. So I'll put square braces on each of these element stuff. And now the only one of these that's complaining is the paths, and that's because this is a type string and this is a type string view. May I ask you a question? Of course. Yeah, what's your question? You can't directly compare these vectors, so I guess I'll have to do... Ooh, I'll have to do a comparison between... each element. Okay. And just to quickly confirm whether strings can be compared against string views, I'm going to take a look at the operators. That's the assignment operator. Where's the comparison? Here. If at least the one is... Okay. String view like. String... Okay, no string views listed here. How do you have your graphics working? I really want to start making applications with the GUI and not just have every app be run via a terminal. Yeah, so in my case, I'm using OpenGL, and I'm doing my own Win32 code, so I'm doing my own Windows. But when I'm inside the editor, all the widgets and stuff is from a library called DRIMGUI. I'll pull up links for that in a second. While it is nice to have that for Linux, a lot of my friends who use Windows find the terminals confusing. Yeah, so graphics is kind of trippy. It's sometimes not very easy to use. Each platform has their own preferred way of doing windowed apps. C++ is in a lot of ways, it's kind of left out in the cold. On Windows, you're like the way that Microsoft wants you to do it is to use C# and use the .NET framework. And then in Visual Studio, you can design your window layouts with the Visual Graphic Designer, where you drag and drop, put a button here, put a whatever there, and then it'll have a code behind file, which is like a XML document that describes what all the buttons are wired to what, and then you like right click on the button and say, give me an on-click call or whatever, and then you in the C# code do the response to that. And like that's the way that they want you to do it. Apple has their own way of doing it. In Xcode, you would use I think it's called storyboards. I forget the exact thing it's called, but you design in a very, very visual way as well. If you're wanting to do C++ and C style stuff, those designers exist, but they're not first party. So like Qt is a library that a lot of commercial companies use for doing cross-platform C++ applications with various window layouts. And that's actually how like OBS is based on Qt. So that's that, but companies will pay through the nose to use it. And I think there's an open source license that's free, but you have to, you can't sell it. You can't sell whatever you make with it unless you buy their license. DRIMGUI is great for setting up windows. I'll pull up RenderDoc real quick. I'm going to launch my my engine editor through RenderDoc so that way I don't have to recompile. Like all of this stuff, the layout stuff with the ability to do, drag and droppable windows or whatever. That's all. Oh, what? It crashed because of the code hooks. That's interesting. I'll have to worry about that later. Inside of RenderDoc, I don't think you can do undocked windows. But yeah, like all of this stuff is from the IMGUI library, but you still have to make the window yourself. So in my case, I literally have Win32 code for this, And then on macOS, I have my own windowing code as well, which goes through their API, which is called Cocoa. It's kind of tough, and you probably don't want to start by doing it the way that I did it. If you're in the C++ land and you want to be able to do fun stuff with like widgets like this, like open the scene file and you can do have all of these, the ability to do like buttons and text boxes you can type in, all of that, I would recommend doing probably JLFW and IMGUI together, and there's lots of tutorials on those two things. From there, you're able to set up your widgets and everything relatively painlessly. If you want to do things like this, like do your own graphics and do your own scenes and stuff, then you actually have to do your own OpenGL or your own DirectX or your own whatever have you. But yeah, there's probably an example for your IMGUI plus GLFW tutorial. There's probably, yeah, here's an example on GitHub. And I'm going to quickly evaluate it and see how good it is. Main.cpp. Yeah, really basic implementation. But yeah, and the Cherno on YouTube, he's got a good series on it. I've tried GLFW in the past, but I didn't have much success with it. I do have a bit more experience with it now. Yeah. The GLFW, I guess there is kind of a feeling of going against like an informational brick wall, like a whole bunch of little functions in the library that you might want to consider. But what I will say is that it handles so many edge cases that you won't know to think of, that if your purpose is just to do like small little projects, and you don't have like an explicit reason to do your own windowing code, you probably shouldn't. And GLFW is a really battle-tested library that makes windowing pretty straightforward. And if you couple it with DRIMGUI, you can it pairs up well so that you can do the docking branch. Oh, I should point that out. That's one you're probably gonna want to look into. I'm getting way off track, but in the DRIMGUI library, if you're going to be using this, be sure that you go to the docking branch. So clicking the drop down to change your branch and go to docking. And I want you. I think everybody should be using this branch instead of the main branch, because it's like, oh, don't worry about it. It's fine to talk to people, and I like to share this stuff. But I would use the docking branch, because the docking branch, it's so much farther ahead than the main branch, and it has its key features that you can take and drag a window out, and it'll spawn another window, and so it's just like another application. In Chrome, you can drag tabs out and then they become their own windows or whatever. You can do that with the docking branch of DRIMGUI. So I'd recommend using it instead of the other. And I'll go ahead and throw that in the chat for you. And that's what I use in Enterprise for the editor. And it's really it's the thing that takes DRIMGUI from being like a toy to being like something you'd use in an actual application. But anyway, back to where we were. We were in the middle of getting the comparison code working, so we needed to determine whether the files we had selected have mixed values. We've changed the type of storage for the paths for the member variable of the texture inspector class, and now we have to do a comparison between a vector of string views and a vector of strings. So DRIMGUI combined with GLFW, look at that. Yeah. A lot of people just say IMGUI, and when they say IMGUI, they mean DRIMGUI. IMGUI is a category of UI. It's not the name of the library. So I'm always careful to say DRIMGUI whenever I talk about it. But yeah, it's a good place to start if you just want to go from doing console applications to doing something a little bit more visual. Okay. So we can't do a direct comparison here. I was in the middle of looking up ways to compare string views with strings. It'd be great if I could just use an equal operator. Okay, all of these comparisons that we have for overloading are for string views directly. There's probably a constructor for string view that takes a string though. So we could possibly basic string view. No, I guess not. I was thinking that maybe we could have an implicit conversion to a string view from the string, and we could do an equality check there. I'm just gonna try it and see what happens. But this whole thing, paths is mixed. That's gonna need to be a block. And we'll do a for loop through every string view inside of paths compare. Yes. So we'll go through every const std string view reference sv in. Wait, did I already do sv? No, I didn't. In paths compare, and then for every one of those, we'll say if paths compare, or sorry, if sv is not equal to, I'll need to index into both. Okay, so I'm not going to use a range here. I'm going to use regular old integers. Int I equals 0, I is less than paths compare size I plus plus. And so we'll go through all of the paths compare, and what we'll do is we'll do a comparison whether paths compare at I equals, does not equal paths field 0 at I. And does that comparison work? It does. It's not complaining. Okay, so I guess we can do a comparison with the string and the string view. So that works. Probably there's an implicit conversion in there that I'm not thinking of. However, I'm going to need to wrap this whole block with an additional check. So say if paths compare dot size equals paths compare, or paths field dot size. I noticed that you use the keyword const often in the method and for loop. What does it mean to have a const there? It's telling the compiler that I'm not going to be changing it. So it's kind of a it's less for optimization's sake and more for the sake of preventing me from accidentally modifying it. When I do a for loop like that, a range-based for loop, I'll just scroll up to find another one. Like here, for const std string view reference, this sv becomes a handle to each and every one of the string views in this vector. It's a reference, meaning that it's not a copy. We're actually editing the contents of the string view when we edit the sv. Hey Jola, welcome. And it's const because I'm not actually interested in editing the view. I'm just interested in reading it. So by saying const, I can't come in here and then say sv equals thing and then like that because it's const. I shouldn't be able to assign to it. You'll see a little squiggle there. So that's more for making sure my intentions are known and I'm not accidentally writing code that will break something because I forgot that I'm not supposed to be writing. Yeah, it's a best practice. And you'll see me passing around things like const reference as well. So like if I do an API call, a lot of times it'll be const whatever reference, and then that way the calling thing is not copying it into the function. Hey, you're welcome. Okay, and so there's an iterator that I'm going through all of the paths compare and comparing them to paths field at the same index, but that's only valid if the sizes are the same. So I'm gonna wrap this inside of another if statement. Dot size. So if they are the same size, then we can do this. Otherwise, we don't. But I'm actually going to do this as an early out style instead. So we'll short circuit the loop if they don't equal. So if the sizes are different, then we know that the field should be considered mixed. So we would say paths is mixed equals true. And then, oops, we'll do a break line here. So we're going through all the paths. We identify that the number of paths in each file differ, so we know that they should be mixed. So we make them we mark it as mixed, and we break the loop, and we'll move on. What are you complaining about? Must be a modifiable L value. Is paths mixed? Why wouldn't that be a modifiable L value? Paths is mixed is oh, because it's oh, yeah, I gotta fix these because I have two values for each of these now. I just forgot to do it on the if statements. Okay. All right, paths mix at 0. And just as a quick reminder, all of these values are arrays of size 2, where the front element, the 0th element, is what we actually put inside the widget. And then if we click the revert button, then we copy the backup values in element 1 to element 0. So we just got to make sure that we initialize both as we go. Okay. Okay, so we'll do a break here, setting is mixed to true. Otherwise, we will do the comparison, and paths is mixed. Oh, here's what we'll do. We'll do if paths if paths compare. Oh, I'm already doing the comparison I need. So if the string at this element is not equal, then we will set mixed to true and break as well. Okay. Got it. So this will skip. This skips. Okay, so this skips out of comparing all the others if we've identified we've mixed value. This skips the same, but it also skips doing the check of individual strings down here, which is important because if I don't do this comparison first, then it'll be possible for me to be indexing into an index that's not actually there in paths field. Cool. Okay, I think we're good on that comparison front. All right, so now we have a picture of all of the fields, whether each is mixed. The last thing to do before moving on is to do a memcopy from the front to the back, so that way we have the is mixed variables. We have the same value in front and back before we start using the front as a widget value. Where are we? Yeah, so this is. Why did I do it this way? This is the equivalent code up above where we do the copy, but like there's no reason for me to do memcopy. I think I was just doing it because that's where my head was. But really, this should just be an assignment. I don't know why I didn't just do it as an assignment. Let let me do that real quick. So the variable at index 1 should be assigned the value at index 0. That's so much easier to read. I don't know why I didn't just do it this way to begin with. All right, but yeah, we'll have to do similar code down below here for the is mixed fields. So that'll be after the for loop then. If load text file. Okay, so this is the for loop. We're going through all the selected files. After we have returned from that loop, we will do the assignment for each of these mixed values. So that'll be, I'll just quickly copy the names, Control C, and then in here I will paste them. And then we will do index at 1 equals the same value index at 0. And I'll shift F to do the formatting. Okay. I think that's looking good. Perfect. All right, so at this point, everything is loaded, and that loading is happening in its own encapsulated call, which is one of the perks of doing this as a class instead of as a function callback. Now we're looking at the inspector GUI code, and I can probably safely stop referencing the header. So now we're referencing the on inspector GUI call. We have a member is error. Why? Okay, so that's referencing fine. We just don't have the IMGUI header included yet. So let's do that now. Include IMGUI.h. And we probably need the internal header too, don't we? Come on, IntelliSense. Come on, IntelliSense. Okay, there we go. Type field. Right, and now we're getting complaints about the variables that we're populating because these are now arrays instead of just being direct variables. And this allows us to have IMGUI operate on a separate copy than the backup copy of the data. All right, this is making some sense. So 0 is the main copy, 1 is the backup copy. Okay, type field isn't. So every case of type field. Yeah, there's only the 2, that's good. So that widget should be the same now. If paths is mixed, 0. Then we will do push item flag, IMGUI flags mixed value. What are you planning about? Oh yeah, this is the pushing the item flags. That's an internal IMGUI feature, so we'll have to use IMGUI internal.h. And these squiggles should be disappearing. We're not using path buffer anymore. In fact, I think there's a stdlib version that I could be using. Yeah, IMGUI stdlib, which gives me input text multi-line. Okay, and so what I'll do is I'll do the input text with the address of the string in the address of the first string in the vector of paths, instead of doing this buffer thing. And this particular thing I'm not going to spend a lot of time on because we're going to need to move from it to a different widget type entirely eventually. But for now, I'm just going to do single path in input text. So this would be the address of, it would be paths field dot front. So paths field is the vector of strings. That's the local variable, but it's an array. We need to do the front buffer for the comparison, and then we get it as a reference, and then we get its address. Cool. That's looking better. And then pop bottom flag, and then we set the ismix value. Otherwise, we will do this for. This is actually literally the same line of code, but the difference is that we're not wrapping it in push and pop item flags. And the same thing will go for the rest of these, basically. I did make this a drag and drop target, so you can drag and drop PNGs onto it. Which means I'll need to change the front value directly. So we'll say dot front dot I think we just do an assignment, can't we? Payload data. So I could do an initializer list here, or not an initializer list. I forget what it's called when you do the constructor with the braces. Like that. That should construct a string, I think. No, doesn't it? Okay. What is payload? That term is often used. Payload in this context is a drag and drop payload. So we have this particular field. So this is the code that does the field. We do input text to give a text box in IMGUI. We push and pop the flags around it to make it look like a mixed field. After that's done, you can say begin drag drop target. And the last item that you pushed, which is the input text box, becomes something you can drag and drop onto. So this is a target. If I drag and drop a PNG file onto it, then this code can execute. So accept drag drop payload gives me a pointer to a struct containing the data in question. In this case, it's a C style string, so data gives me the string, and then data size gives me the length of it. So it's just a path, basically. This allows me to fill the field with a path that I dropped in from the content browser. I'm just trying to think of the best way to handle this. I suppose I can invoke the constructor directly. So payload data payload data size. Does that work? I guess not. Okay, whatever. So I'll construct it. I think I'm just kind of wrapping my head around move constructors. So I'm just going to quickly double check that this will do what I think it does. If I do an std string constructor on here and construct it from that, payload arrow data payload arrow data size. If this uses the move semantics that I think it does. Oh, hang on. Maybe I misunderstood the situation entirely. Data is not a character type. Oh, that's why it's been complaining at me this whole time. Okay. That's frustrating. I have to actually cast this to a character type. Like that. The data comes back as a void pointer. It needs to be a character pointer. And then that should be fine. And this needs to be like that. Okay. So does that work? Come on. Expression preceding parentheses the parent call must have pointer to function type. Screw it. Do it like this. If I'm understanding Move semantics correctly, I think that assigning a string to another string when the string is an R value, I think it does. Why are you complaining? What's wrong? So data size is an int. Needs to be size t. Right? Oh, come on. I know that there's a string constructor for this. Yeah. Character star s size type count. Yeah, no, it's just that's how I feel about IntelliSense sometimes. It's not like I want to do a thing, and then it complains because I did some weird thing wrong that I wasn't keeping track of. And yeah, const char star, and then payload is size t, or the second parameter is size. Yeah, so you got const char type star s size type count, and then a custom allocator if you want. Well, it's not coming in as a const, so I can cast it to a const type if I want, but the data, if we take a look at the return value of IMGUI payload data, it's just a void star. It doesn't have to be a string. I'm just using the .png payload extension to do strings, but that's my own convention. This can be used to pass objects, any kind of data. You just get its address and how big it is. I'm not at all convinced that. Well, anyway, to finish answering what you mentioned, this is a void star, which means I can cast it to any type, any other type. It's just a regular address with no type information attached to it. You can cast it to a more strict type, so I can make it a const star. I can cast it to a const character pointer. Though really in C++ style, this should be like static cast, like this. Like that is how you would do it in C++ style, but I don't think that'll make a difference. I'm going to restart IntelliSense. I'm thinking that IntelliSense is maybe just being a dingus. Restart IntelliSense for active file. Okay, no, it's still complaining. Expression preceding parentheses, but a parent call must have a pointer to function type. I'm starting to get really annoyed. Let me go to the content browser. So I've done this a bunch before, and I'm sure that it's done this way. .front gets you the first element of a vector. So if you have a vector of any type, you do .front, it'll get you a reference to the first object. And I'm using that in this case because I currently only support 2D textures, and as I add support, I'll be looping through the vector, but for now I'm just setting the first value, and that's going to be the one that you use in the texture. God damn. Wait, it would be sprite. Sprites is where I did this before. Okay. So what I did here in the drag drop target for the field for EP texture dropping in the sprite component is I accepted the payload. I got it as a const, InGui payload star. That's what I did in my code in the other section. And then I casted. Oh my god. That's it. Oh, that's so frustrating. Okay. And this is something that I could probably blame C++ for this. Data is a mutable object. Okay. I am used to this sort of thing being immutable. So basically, this void pointer is a public member of the payload class. So they don't use a getter to get it out. They just you're just supposed to use it directly. It's always something simple like that. So I don't do arrow data, and whatever I do arrow data without any parentheses in front of it. Okay. God damn. All right. So I can probably do. Yeah, that's basically. Yeah, I can probably do construct in place. I'll do it like this, which is what I tried to do in the first place. Expected a. Oh, that's not going to work. All right, so we'll do the std string construction explicitly, and then I just want to, for sanity's sake, confirm that this would construct with the move semantics. Replaces the contents of those. Okay, number 2 is the move semantics. 1 takes a R value reference, mutable, and then yeah, okay, so that's good. So even though I'm explicitly constructing a SD string here, this object is not going to reallocate twice. It's just going to take the data store that's allocated here and change the address of the one that's in here to reference it. So that's good. And then we don't have to do memcopy anymore on that. And then paths is mixed equals false. In C#, I love putting my data in as public to avoid creating get setter. Get setter is so boring, and yeah. Now, yeah, something I love about so getters and setters work differently in C# because they're like an official part of the language, whereas in C++ it's just an idiom. C# has properties, and that's great because with properties you can do you can make them read only. You can do a getter and a setter that does something when you access it. But the key is that what just happened to me, the thing that was giving me grief over this data member, that would never have happened in C#, because in C#, you just access the property the same way you would any other variable. Whereas in C++, because it's an idiom, it's not an actual like properties are not a thing in C++. If you want to make something read only, or if you want to associate a getter with a variable, you have to privately declare the variable so it's not visible, and then publicly declare a function that gets it. So I was doing this because I was thinking that data was a function that returned the private member variable. Whereas in C#, the code would be identical either way, and so you can't accidentally do what I just did. So that's a +1 for C#. But there's plenty of other things that I prefer about working in C++. So paths is mixed is false. That's not right. That needs to be at element 0. So, because when we go to make an edit by dragging and dropping the value on here, we are changing this from being mixed to being edited. We'll come back to this in a little bit because we're gonna also do something in here where we track when it's been edited. Oh no, we're not. So we're going to be populating the contents of the file only when you click the apply button. So at that point, whatever's in whatever's in paths field at 0 will be saved. Okay, cool. I think that's good. And then we have just a few other fixes to worry about. On these, we need to be accessing the 0th element of these arrays. Min filter field isn't. Yeah, that's fine. But it needs to be casting the min filter field. These need to be 0 accessed. Yeah, this gets a little bit tricky because some of the code that's wrong doesn't have squiggles in this case, because I have is for what was a Boolean value. The Boolean values are now arrays, which means that it's still a valid line of code, even though it does something different. If I don't remember to put the array accessor in, what it'll do is it'll just check to see whether the array's been allocated, which is a no op, but doesn't do what I want it to do. Okay, that's looking good. This needs to be element 0. Yep, and then that needs to be element 0. This needs to be element 0. That needs to be element 0. I feel like Oprah, but I'm handing out element 0s instead of cars. Yep. Okay, and the rest is fine. I think that's it. All the little red squiggles are gone. I think we're back to where we were, but now everything's encapsulated nicely. Cool. Now, unfortunately, we're still not ready to compile because we have to implement the API to register this. That's going to be a little tricky, but it'll be rewarding. It's going to be one of those things where once it's done, we'll have a nice clean API for extending the editor, and that's exactly what we want. And we'll be able to use that for setting up all kinds of other inspector types. I'm going to take a quick little break before I do that, though. I'll be off for probably 10 to 15 minutes. When I get back, we will get the register file inspector API to start working with the templated registration, and then we can confirm that the texture inspector is working, and then go from there to work on serializing the apply button. I'll be back in just a little bit. Alrighty, we're back, and I'm unmuted and got the camera and got some tea, and well, it's still too hot, but we're back. So now we have migrated the texture inspector code into its own class, which gives us a bunch of key benefits. Probably the biggest of which is the encapsulation of the state into an object that can be deallocated. We're going to use the special arena allocation meta class or texture class that I was demonstrating towards the beginning of the stream. And now we just got to get the API to use it correctly. So I'm going to use my experiment from the weekend as a model. So for it, I had this API called the inspector registry. It has a couple of templated components to it. Those being the template for a factory function, which takes a reference to a polyunion inspector, or polyunion being the type. So it takes a reference to the variable that can house the current inspector, and then we in place or construct the new one from it. So this is pretty much going to be the same. This is the implementation function for the registration call, and this is its own thing, so that way we don't have to expose the internal global variables to the game developer. Yeah, so all three of these things will make the trip. Let's head back to where we got this going. We did, okay, I actually already copied them in here. So here's the file inspector factory thing. I'll do the underscores at the beginning to indicate that these things are not part of the API. They're just something, they're just an implementation detail. I'll probably give it a little bit of a better name though. What do you think about this? No, it should be, no, it should look just like that. I think that's fine. For the templated type, I'm going to say type of file inspector, just make that a little bit more clear. We have the file inspector class is actually defined as a type. We did that earlier, so that's good. It receives a polyunion of file inspectors as a mutable reference. We call that inspector out. And then we have a static assertion, so that way we're ensuring that whenever we call this function, we are doing it of a subclass of file inspector. NCV, I did the same thing in C# to avoid using getter set. Yeah. And it's actually a good thing in C++ to do that too, in a lot of cases. And in fact, there's a lot of hardliners like Casey Muratori or Jonathan Blow that will say you should never ever use getters or setters. That you should just trust the developer to know to know better than to write to a value that shouldn't be changed. I'm in the middle somewhere. Yeah, so T file inspector has to be based on file inspector. And if that's not true, then we say T file inspector must derive from file inspector. Yeah, and odds are that this will never trigger for a user, because if a user is using the API correctly, yeah, if they're actually using the API call, which is this, then their assertion is going to fail inside of this function. This is more for my sake. Okay, and then the implementation function is just declared here, not used. It takes a extension string as a const reference, and then we take in the factory function, which I'm using std function for this. Std function is a little bit of a nicer wrapper to use than a C-style function pointer. I don't really see much reason for me to not use a C-style pointer, but I'll use std function because it's just a little bit I don't know. I'm trying to think. I'm trying to remember why I did it. I'm pretty sure there's a reason. I think it's because I am storing them in a map, and it's just a little bit. Yeah, it's a little bit nicer. So this will give us the address of the. Let me think about this. This will accept the address of the factory function, and the factory function will be used inside of the register file inspector call, giving it a reference so that it'll have an address and it'll be defined. And then, yeah, okay, I think that's making sense. Inside of the register file inspector call, I'm actually just going to copy this whole thing and paste it. Because basically all it does is it calls the implementation, passing in the extension and the address of the inspector. The address of the factory function. So file inspector factory, passing in the type that we pass into register file inspector, gives us a factory function that instructs the that emplaces it into the polyunion that we are going to put inside the implementation file. Okay, so actually I'm surprised that I don't have to make any edits, really. I just copied and pasted the stuff from the header in the other file. And that seems to be working fine. So let's go to the implementation now. And this is where things get a little bit messier. So we'll have to have a polyunion global that's going to represent the inspector. We're also going to need to have the inspector factories map, which associates the strings with the function pointer. So we would, when we go to load the inspector on the editor side, it will look up the extension and then get the function that it needs to call to create that inspector. Yeah, so let's do that. We'll need to open up editors.cpp. This is where this is going to live. Actually, we're going to need to change a number of things in here. So for starters, we're going to do away with this. Registered file inspectors is a good name, but this is going to be a polyunion now. EP polyunion. But I guess I need to include it. Oh, I haven't even included it in this header. Okay, let's do that now. Include enterprise core polyunion.h. This will be an AP polyunion of type file inspector. And that'll be the replacements. That'll be the replacement for this. This is going to be needed in the editor project, so I will not make this static. I will declare it though in editor.h in the internal folder. So this is going to be registered file inspectors is going to be EP polyunion of type file inspector. Yeah, and then I'll need to do the inclusions here as well. C++ does transitive includes, but I don't. I think it's a bad style to depend on having the includes be in a nested header. So I'm putting the polyunion header in each of the files where I'm using it. I also need the file inspector, which is going to be in include enterprise editor file inspector.h. Okay, so we got polyunion, which is now EP : polyunion. Um, I think I'm going to take polyunion and remove it from the enterprise namespace. It's such a general structure. I'm thinking that it probably would be more valuable in the global namespace. I mean, I could put it in like the STD namespace, but that implies that it's in the standard library. No, I'll leave it in. I'll leave it in the enterprise header or enterprise namespace. I'm just indecisive, and I probably will be until this is done. All right. File inspector, polyunion. So what are you complaining about? Oh, this doesn't match a declaration somewhere else. Oh, I have to do EP graphics. Oh no, EP. We're in the editor namespace. File inspector is an editor namespace class. So what's the problem? Detected during instantiation of file inspector factory, incomplete type not allowed. What's the incomplete type? Not sure what I'm missing here. Let's take a look at the way I did it in the original. And this is all tested code. This builds and runs perfectly. Polyunion file inspector. By reference. That's it. That's all I need. Oh, hang on. This has to do with the polyunion class itself. So I'm not exactly seeing what I changed. I've pretty much just copied and pasted this. Did I make any? I mean, the changes that I made were to these functions to use the aligned free versus the standard free. And that's about it. Everything else is templated, and I know that this works. What? I didn't change anything. Oh, IntelliSense, goddammit. I didn't change anything, and then it just fixed itself. So apparently it was just IntelliSense. You can kind of blame IntelliSense's problems on C++ as well, if I'm being honest. If it wasn't such a convoluted language for computers to parse, then it probably would be more correct more of the time. It's far better in C#. All right, so that is fine then, and I don't know what it was so mad about. Okay, just to review. we emplace the file inspector into inspector out dot emplace. Yeah, that's good. And then that's all perfectly fine. Let's do the implementation file now. So now we're using a polyunion of file inspectors, which is declared in the internal header now, so that way I have access to the registered file inspectors on the editor's side. The register inspector call, here's the old one, here's the new one. I'll comment out the old one. The new one accepts the component name, the callback. If registered component inspectors.get has component name, then we will say editor register component inspector attempted to register a second component inspector, because that's bad. We only want the one. Then we have a return otherwise. And then we register a component inspector for. Yeah, we save the callback. Oh, I'm reading the wrong function. This is bad. I need to replace that. Hey, Olin. Yeah, break was good. Got some tea, got some relaxing done. My sister had been COVID positive for a little bit, and so we were masking up at home, and now she's better, and it's great. So I was able to pet the cat again, because her cat was, running around, probably being a little plague animal, spreading the plague, but isn't anymore. So that's good. Yeah, so I need to copy the implementation from here. This is the CPP file. The implementation is real simple. All we're doing is we're storing the factory function inside of the structure that we're using, which in this case is the registered file inspectors thing. So I'm going to select this whole business. Actually, I'm going to just comment it out and then paste in the implementation. And we'll probably do this again for the component inspector. We'll probably encapsulate the component inspector using polyunions again, so that way they don't all have global state, even though it's modal, even though it's a state pattern. Yeah, and then this is now called registered file inspectors. So registered file inspectors at the extension, we plug in its factory. And then on the editor's side, when we do the load inspector, we call it the factory function. So this is not a map associating strings with file inspectors per se. It is associating. Yeah, this needs to be. I need to change this. It's associating not the string with the actual polyunion. That's something that we'll declare in the. That's something we'll declare on the editor's side. But I need to actually instead get an std function of type void, and then it takes a polyunion of file inspector type by mutable reference. And then yes. Yeah, I think that's right. Yeah, void polyunion. Yeah, so that's good. And then what are you complaining about? Expected another. Yeah, I need another one of these. Because the function has one, and then the map has one. Okay, what are you complaining about? Okay, good. All right, this is looking better. Okay, and then on the CPP file, this is also going to be taking a std function. There we go. So we're associating the string with the function that accepts a polyunion reference. Okay. And that'll make this visible into the editor's side, but not visible to the game side. All right. What's the problem? No operator. This is an EP polyunion. Hey Joel, yes I am. I'm at 4 hours and 14 minutes. I want to wrap this up though. Should eat something? Probably should. You're right. It's 2 p.m. I'll have a big sandwich when I'm done with this. Yeah, I try. I'm just not very good at it yet. But yeah, we'll probably be done here in like 30 minutes probably. Well, there's still something else I want to do after I've gotten this part done, and that's get the serialization done. And I don't know how long that'll take. We'll see. But I won't be on here for very much longer, I don't think. I don't think this is going to be a 6-hour day, for example. I think this will be just like 5 hours maybe. Yeah, so now the registered file inspectors takes the factory function. This is now arguably a inaccurate name. This should be file inspector factories, like that. Should set a timer 1 to 2 hours so you don't forget to drink. Helped me a lot. Yeah, I took a bit of a break. A little bit ago, I went out and got some tea. If you were worried that I was literally sitting in the chair nonstop for 4 hours, I did take a 15-minute break. Thanks though for your concern. Yeah, and these need to be applied. Cool. So this is looking better. File inspector factories. So now we have file inspector factories storing the functions that we will call inside of the editor layer to create and populate the polyunion. Okay, cool. We're nearly there. Okay, and then on the CPP file, I think that's literally it. The polyunion declaration that I've got here and the load inspector call, that's all stuff that's going to happen on the editor layer. So what are you complaining about? It's file inspector factories. Oh, this is the inspector code, and it's going to be wrong. Okay. Taking care of myself more weirdly helped me performing better in games. Yeah. Self-care is key to doing anything well. If you're not taking care of yourself, then you can't really take care of anything else you want to do. It's Maslow's hierarchy of needs. full stomach means better brain. I always forget to eat and drink. Yeah, I'm pretty similar. If I'm working really hard, I'll forget to do stuff like take care of my body. Okay, so this is actually the area where we got a problem. This is complaining specifically because we haven't implemented the load call yet. We'll take care of that in a minute. That's looking good, that's looking good, that's looking good, that's looking good. So if I press F7, I should have compilation errors, but only on the editor layer, I think. We'll see how this goes. Well, I'm gonna let you code in peace. We'll go to bed. Yeah, man. Good night. Thanks for tuning in. I'll catch you later. Okay, so let's take a look at the build errors. I should only be the only build errors that I see are in. Oh, editor.h has some. I was thinking that this was the editor layer. This is the editor.h header, which is in the engine. So this actually has to be an EP polyunion. I forgot to scope these. Good. All right, F7 again. Okay. And again, we are expecting some errors compiling, but I'm hopefully seeing them only in the editor layer. Oh, no, we still got some in the enterprise layer. Hang on a minute. Polyunion.h. What are you complaining about? Allocating an object of abstract type editor file inspector. No, we're not. Are we? Where am I doing that? So this is happening during an in-place call. Really? It is? But I haven't used it anywhere. An instantiation of function template specialization, editor : register file inspector. Okay, let's take a look at the register file inspector call. Here. So this is what it's talking about. We pass in the base class. Oh. Yeah, that should be of type file inspector. So I don't know how this happened actually. I had tbase be the class template parameter name, and then I used tfile inspector in here. Must have been an issue with copying and pasting. Okay, so those warnings disappeared. What do we got now? Destructor called on editor file inspector that is abstract but has a non-virtual destructor. Okay, so this is in the instantiation of a polyunion of file inspector type. File inspector has a virtual destructor, doesn't it? Oh, it doesn't. I didn't make it virtual. Damn it. Okay. Virtual file inspector. Yeah. And is the... Yeah, I just did it like that. I don't think I need to do equals default now that I'm thinking about it, because it's not implicitly deleted. It does need to be declared virtual. So F7. Cleanup overrides a member function, but is not marked override. Oh, yep. Yep. Oh, and for that matter, do I have a definition for it? Did I put a definition in here? Okay, I did, yeah. Cleanup overrides, yeah. It's all the same warning, actually. Come on. All right, and then what do we got now? Inspector.cpp. Okay, finally. So this is the one I was expecting. This is the error that is occurring because we haven't implemented what we need to on the editor side. But looking at the compiling, linking shared library engine.dll. Okay, so the engine.dll failed as well. Undefined symbol public file inspector destructor is undefined. I'm going to assume for the moment that this is unrelated to what we did in the engine layer. Well, no, I can't, can I? Cut copy paste has been created in 1973 to 1976. What a genius, we still use it. Yep. Did you cut, copy, and paste that? I think I remember seeing that meme around. Like, forever ago. Undefined symbol public virtual cdecl file inspector referenced in textureinspector.h. I don't need to call the default destructor, do I? This is the object-oriented stuff that I don't do very often, so I'm having to gut check myself. pretty sure that if I don't declare... Oops. I guess in my test code, so this is the test code that I did over the weekend when I was testing how I might do this, or experimenting to see how I might do this. I guess I did have a destructor declared and defined, but that was only for the sake of confirming that the destructor was called. I overloaded it. I overloaded it so that I could put in a message. I'm going to comment those out and see what happens. To do my brackets in C# I use Alt plus 123 and Alt plus 125. I wonder in what year it has been invented. I mean, you're joking though, right? maybe this is a maybe there's a quirk about international keyboards that I'm not getting. Yeah, so I've commented out the destructors on this. Let me run the test on this guy again. Confirm that this didn't break anything. Yeah, so my tests still work, even though I don't have a definition or declaration for the destructor on Custom Inspector A. So I don't know what I'm missing. No, I don't find it faster because my keyboard at school kept changing language, so I couldn't find the bracket on my keyboard. Oh man. I find it faster. Yeah. That sucks. I'm gonna have to think eventually. I'm gonna have to think kind of hard about these problems eventually at some point. I know that this is getting a little off topic again, but Jonathan Blow's programming language, Jai, I'm not sure that I like Jonathan Blow personally. I think that he doesn't says enough that makes him sound like he's a jerk in real life, but his programming language looks like it's going to be really good. And he was talking on a stream at one point about how the international usage and international keyboards and stuff played a factor in a number of the design decisions he had in the language. Just making sure that keyboard keys were certain characters were easy to type in all languages. I got him on following his puzzle game and Jai's Advanced. Yeah, that's looking like it's gonna be his Sokoban clone. That's looking like it's gonna be pretty fun. He does good games, and it's funny because he's like a celebrity for the kinds of games that he does. But he's really only done 2 big ones, right? He did Braid and he did The Witness. Has he done any other big ones? I know that he's worked on other stuff, but his actual company. Yeah, so best known for those 2, but has he actually done anything else before? Like, his Braid was his first indie. I guess that's it. After Braid, the only game he's released is The Witness. But yeah, like they were both so good that, like, you know, he's been put on the map. Just doing one, I find it miraculous. Yeah, making a game that's even like releasing a game that's bad is hard enough. But doing one that actually has got like critical acclaim and is really popular, that's really hard. Anyway, yeah, so the problem that I'm coming across compiling in here it's not because I failed to declare the child class's destructor. The parent class has the virtual destructor, the child class doesn't have the constructor, and it still works. So yeah, so I'll have to put this on the back burner for the moment. I'm going to do the editor API, and then if we're still having problems, because maybe there's some kind of weird template weirdness happening with the inclusion of the header inside of the editor project. But we're still having problems after I've implemented the correct API for actually populating the inspector. Then we will address it then. But cool. So anyway, this is where we actually do it. This is the inspector, inspector.cpp. Inspector.cpp, now I'm going to give it a static, I'll do it right here, static polyunion. And I will do this with include enterprise core polyunion.h, and we will do a static ep polyunion, and this will be of type file inspect, or ep, no, it would be in the editor namespace, so I can just do file inspector. And this will be current file inspector. And I will actually construct it with 1K of memory. So that way, the only time it will ever need to reallocate is if you if you register an inspector that has more than 1 kilobyte of state. And if it has more than 1 kilobyte of state, then that's huge. So that might be a problem. But if it does get to be bigger than 1K of memory, then we will reallocate the internal arena, and it'll still function correctly and fast, which is what we want. Okay, file inspector though. Did I even include the file that has file inspector? I did, because it's in editor.h. No, that's not right. Is it? It's in the public editor.h. Okay, it's from a nested include. Yeah, so I'll want to do that include here. Make sure that it's present. All right, so now we have a global on the editor side, a variable that will hold whatever current inspector we have for files, and then down here is where we would normally invoke the function. So we're gonna have to change the structure of this a little bit. So content : selection change this frame. This variable, this boolean, is set on the content view when you change the selection. So when that happens, that's the point at which we will allocate the new inspector. Hang on just a moment. I got a call on my phone I gotta pay attention to. All right, I am back. Had to step away for a second. I had a call from FedEx. They were trying to find my place. I got a MacBook battery coming in, which I sorely need. Yeah, that should be in here today, and I'll be able to fix my MacBook tonight or tomorrow. Anyway, for this code, we're going to need to do a little bit of restructuring. So selection change this frame is going to be true on the frame that we select new files. And it's at that point where we need to know the extension. Hang on a minute. This structure is called File Inspector Factories now, but it previously was the callbacks, the onInspector GUI calls. So if there's only one extension, we get the extension, and then what we did before is we then invoked the callback directly. And this is something we would do every frame. And that's not great. So I guess we'll have to take a look at this. Look at this call from the beginning. This is the draw call on the inspector. So this happens every single frame. We do the UI on every single frame. So there's the begin on the window. If selected entities dot size. If we have any entities, we will then get so this is all the transform component code. That makes sense. And that's all tried and true. We're literally polling every frame for the selected entity data. And one reason why we do that is because it will update in real time if the game is simulating. So we can't simply cache it. We do have to ask the entity component system for that data. However, at this point, this is still components. So after this if block, we have selected files.size. So we know from this assertion that we can only select entities or files. We can't do both. So we can just ignore this block for now. If we have selected files, every frame every frame we loop through them, okay, so we're going to want to restructure this to do something else. Really, the only thing we need to do every frame from the inspector's point of view is call the onInspector GUI function. Everything else is just done on the one frame that we've changed our selection. So, So if we've got here's what I'm thinking. I'm thinking that we just don't conditionalize this, and we just every time we call whatever the current inspector is. Oh, I've got a better idea. Okay, let me think this through. Yeah, so what I'm thinking is that when we change the selection, we construct a new inspector. We could make the file inspector and the component inspectors derive from the same inspector class. So file inspector is already abstract, but it would be based on a simple inspector class. Hey Devil, welcome back. I am thinking my way through the implementation of the inspector and thinking of better ways to handle it. I'm thinking that what we could do is we could make the file inspector and the file inspector and the component inspectors. We can make them based off of the same type, and they both have an on-inspector GUI call. And then inside of the inspector itself, we would have a polyunion of just type inspector. And then no matter what thing we have selected, or if we don't have anything selected, we could just invoke the current file inspector, or the current inspector. Let me think this through. Call directly. So this call would be as simple as like current dot on inspector GUI, like that. And then we would have all this logic happen once a frame, with the exception that the component inspector will need to update every frame. But it could do that inside the on inspector GUI call. So I'm sorry, I know I just got here, but yeah, what's on your mind? I'm gonna do a pro-con list. My pro-con lists tend to look just like regular lists, and I just list random thoughts in no particular order. So we're talking about common So the first main perk is that this considerably simplifies the draw call, the inspector draw. We could then separate we could implement non-selection inspectors as well, generic stuff, meaning that we'd have like specialized error messages, or I don't know, other things. We could also easily add more categories of inspector. I like that perk quite a lot. You use WinAPI for your graphics with the one graphics library that starts with IM. Yeah, dear IM GUI. So for me, I do my windowing using the Win32 API, and when you do that, you have to. That's when you do your OpenGL context creation. So if you're going to be using DirectX or OpenGL, you do your context creation at the same time. So you kind of have to do if you go that route, you have to do the OpenGL or the DirectX stuff yourself. And then from there, you invoke the Dear IM GUI calls to get set up. Dear IM GUI is basically just like, it has a couple of functions that you call in your code hooks, and it's not dead simple. It does require a little bit of thinking, but it does amount to just a couple of function calls. It's just that you'll have to know what you're shooting for to know what to do. If you look at the Dear IM GUI code, there's examples for how you use all kinds of different APIs. There's one for Win32, but there's also one for GLFW. So if you're wanting to use GLFW, there's literally just open up the project, and they have code that you can just copy and paste and then start working with it. Win32 is a little trickier because it didn't officially, the docking branch of DRM GUI didn't officially support OpenGL plus Win32 until I added support for it. But if you're doing Win32, you're probably doing advanced stuff anyway. You can probably handle that yourself. Okay, yeah. So I think I'm gonna go ahead and add another layer of abstraction. This is the kind of mess that I try to avoid with object-oriented stuff, but it just once it's ready to go, it'll actually be a lot easier to work this way for the editor. So I'm going to go ahead and make the file inspector based off of another class called inspector, and that'll be how that works. Alrighty, I'm just trying to stick with simple stuff, so I'm going to use OpenGL. Yeah, I'd say OpenGL is the easiest to learn. You'll find all kinds of tutorials online for how to do things. If you look at the DRM GUI section, it'll show you how to get started. IM GUI code itself takes a while to learn because there's like a whole bunch of features in there that you'll have to like figure out like how you can make the layout that you want. But if you just want a simple window that displays something, it's actually really straightforward. I'll real quick there's an OpenGL tutorial by Brian Wills, I think. Not that one. There's several, but there's one in particular that I'm a huge fan of. This one is my favorite. LearnOpenGL.com. I'm pretty sure Brian Wills does this, doesn't he? I'm not sure, but it's a great one with videos in every single page, and I would highly recommend it for getting started. But yeah, anyway. So this is now going to be, yeah, of course. So this is now going to be based off of a class called inspector. So we'll need to do a little bit more work, but it'll be worth it in the long run. Oh, don't worry about it, Ben. You're good. So we're going to need to do an inspector.h header somewhere. But you know what? There's a con that I'm not thinking of. Currently, we associate the selected file extension with the inspector that we grab. But fundamentally, selecting a bunch of paths and selecting a bunch of entity IDs are different under the hood. Okay, you know what? Yeah, I'm going to abandon this plan and spend more time on what I actually care about. I use a Linux architecture, so I have a bit more trouble with that, but that shouldn't be too hard to figure that out. Yeah, the GLFW supports Linux. I'm like 99% sure. So that'll make that simpler too. I've never worked with Linux, but OpenGL is ubiquitous. GLFW plus OpenGL, you can do it on Mac, you can do it on PC, you can do it on Linux, and it works perfect. Well, it doesn't work perfect on Mac, but it works well. It works okay. The trouble with Mac is that OpenGL is deprecated, and they only ever supported OpenGL 4.1, which kind of sucks, but okay. Yeah, so my schemes. We'll have to go back to the drawing board. All right, I'm gonna abandon the idea of doing a master base class for all inspector types. I'm gonna treat these as separate. Just all the builds they have are Windows specific, so I have to make a build script. Yeah, so you have to compile yourself. Aren't they I think GLFW is CMake based, right? Yeah, CMake. So you could use CMake to do it. If you're familiar with CMake, you can. But it's a little tricky if you're not familiar with CMake, because it's admittedly CMake is pretty opaque. But if you wanted to do your own makefile, you can do that too. Okay, so yeah, so we're looking at the selected files block. So this code's gonna have to run in the same, where we check the extensions. But that's gonna have to be handled somewhere else. I'm gonna open up the content browser. I suspect that there's a place in here for making this simpler. I don't use CMake. You should. CMake. It took me way too long to get started with CMake. Enterprise. I started Enterprise before I really understood how to use Git. I started it before I really understood how to use makefiles, and I was just working with the Visual Studio solution. I first learned how to use Premake because I saw the Cherno's video YouTube tutorials on it, and it seemed really intuitive. And CMake didn't. But eventually, I needed to have advanced features in my build system that Premake couldn't offer, and it wound up being too cumbersome to use on Mac, at least, going between Mac and PC. But yeah, CMake, once you know how to use it, it becomes really easy to make portable projects. I think I want to do CMake for every C++ project I do going forward, to be honest. But yeah, it takes a while to learn. It's kind of obtuse. Okay, so every place where I say selection change this frame, I could replace with a function call where we parse out the details we need to know in the inspector. So this would be, I'm thinking this through. This would be separate from the draw call. We would have something like void on selection changed, or on file selection. Yeah, on file selection seems right. And it would take a list of files. Currently we put that in selected files, so that there is a global that we could use. However, we wouldn't actually need this to be a global if we did that. Where is selected files in use? Where do we use it? We use it in content.cpp, pretty much to populate it, and we use it in inspector.cpp. And that's it. File inspector coincidentally uses the name selected files inside of its init call, but what we could do then is we could just eliminate that variable, or that variable and the selected files variable, and then simply invoke a function that receives the selected files. Selected files is a set of std strings. I'll go ahead and make it a set of std strings here as well. std set std string. Well, actually, now that I'm thinking about it, we do need to track selected files, because we loop through it when we do the icons, don't we? Don't we? Where do we loop? I know we loop somewhere. Files in current dir is what we loop through. So yeah, so okay, but when we do the okay, so actually we do need to make this a variable that's local here, because we check to see whether it's selected when we call ImGui selectable. So if that's the case, selected files doesn't need to be passed as a parameter to this call. I can just do a void that takes no anything, and we can just do the work here. So okay, I think I'm piecing together what I want to do. So any place where we would change the selection, like these places, we would instead invoke onFileSelection from the inspector. Okay, so let's go to inspector.h and we'll declare it. I'll call it onFileSelection changed. It's a little bit better for an event name. And then inspector.h should be included in here as well. So we could do on selection on file selection changed. Okay. Oh, but it's inside the inspector, so it'd be inspector : on file selection changed. Right? Oh, okay. Actually, haven't included the inspector, so let's do that. Use inspector. Cool. And then down here, we can invoke inspector on file selection changed. Right? Good. Okay. Making progress. So let's do it. I'm going to comment out the selection change this frame. That Boolean is not going to be used at all anymore. And then instead of setting it to true in the places that we did, we will do inspector on file selection changed. We also don't need to clear it because it's not state anymore, it's an event. All right. Okay, now all the red squiggles are gone. Okay, good. And on file selection changed. We will now do a lot of the stuff that we were doing inside of here. So we search for selection change to this frame. Previously we were just passing it into the callback for the browser. Um, right, okay. So when this is called, we would identify which file inspector we want to use, and then populate it. Okay. So that's done here. So we go through and iterate through all of the selected files. We identify all the extensions, and then we identify whether we have multiple extensions or what. If extension counts equals 1, then we do the call. So I'm going to take all of this, this whole thing, and cut it and paste it into here. And then in here we had if selected entities dot size. So we don't have selected entities or files at the same time. So what I would do would be if selected entities dot size, I do the entity inspector, else okay, I think I'm getting this. Else we do the file inspector. And that's going to be done by invoking current file inspector on inspector GUI. But it's possible that we don't have one at all. So this will actually be another if statement. We'll do if current file inspector. So if we currently have one, and this is a thing I built into the poly union, is that it'll evaluate to true if it's currently got a value. Then we would call current file inspector on inspector GUI. And so that really simplifies the draw call. And it limits the draw call to only doing the GUI. The state of it will change up here for the initial state of it. Cool. So on file selection change. So first thing we do is we check to see if there are files. If there are not, then we want to clear the current inspector, so we don't have an inspector. And that's actually totally fine API-wise. Like a totally blank inspector window doesn't cause any confusion. Literally, there's nothing in there when you don't have anything selected in Unity. What about Unreal? I'm not sure about Unreal. I don't think it really matters. So what we'll do is we will, on file selection changed, we'll call current file inspector dot reset. This will delete the inspector in there if there is one, and then if there are selected files, we'll populate. Okay, and it looks like there's a little detail here. It says select an object to view details. So we'll probably that's a helpful little message. I don't know if I care about it. I don't know if I care about doing it myself. I'll worry about that when it comes time to beautify the enterprise editor, but that's unimportant for the moment. So right now, the whenever we change the selection, we delete whatever file inspector we've got, and then we will set it in here when we have one. So this is where we do the extension counting. Extension counts, and we make an STD map of all the files with that extension. We go through all the paths and selected files. We get the extensions. Okay, and then extension counts equals 1. So if there's only one extension, then we will do this. We get the extension, and then we instantiate. Let me grab the example we were working with here. In the inspector registry, we would have a load inspector call that essentially just resets the inspector, which we already did. We just did that on the start of the on file selection changed, and then we check to see whether we have a factory present for. Okay, I think I'm getting it. Okay, I think I'm following through. So the factories are present inside of the editor header, I believe. Let me look at this. Registered. So file inspector factories. They're inside of the editor internal header. So we have access to the factories. So you would say if file inspector factories dot count, and we have the extension in question registered. So that'd be .eptex or whatever your asset name is, or asset extension is. So if we have it, then we simply get the factory function out of the inspector factories and call it. And we pass in the poly union that we care about setting. Okay. So we'll do const auto reference factory equals file inspector factories dot file inspector factories add extension. So this will get us the function to call. And then we can do factory. And then we just simply pass in the poly union. So the poly union would be, what did we call it? It was current file inspector, like that. And then the factory function. The factory function takes and instantiates with the default constructor, instantiates the correct file inspector, and puts it into the poly. Okay, good. Good. So it injects the dependency there. And then we have to call init. I think that's about it. Current file inspector init, and you good? All right. Too few arguments in function call. All right, we have to init it with the files. So we have to pass in the selected files, which is a set, and init is expecting a concept reference. So yeah, that's perfect. And then inside of the texture inspector during init, that's when it loads up the YAML files and does all of its setup and gets its initial state working. Perfect. Trying to teach someone with a Unity background what is a constructor. Oof. Constructors are all over Unity, though. Because they're constructors. Factories are in Unity. Oh, whatever. Yeah, it's I have mixed feelings about how Unity teaches programming, because it doesn't really. It teaches you how to use Unity, and it doesn't teach you how to use it well. Sometimes it does. It does. Unity's tutorials do go over things like object pools and whatever. But I wonder when they are taught in Unity. When they are taught. I wonder when they are called taught in Unity. I got no clue in the background. Yeah. I don't know. I've done some of the Unity tutorials. I haven't really done them all, because like a lot of it goes over things that are really kind of basic, like Hello World style programming. But yeah, my impression of it is that it's like it teaches you just enough to get started, and from there you have to like take a programming course. Okay. Yeah, I think that's it actually. So let's review what we've got. On file selection changed, if we have any files, well, first thing we do is we reset the current inspector. So this will delete the instance of the inspector inside of the polyunion, and then we parse through the list of selected files. We identify how many extensions there are and what the extensions are, and then if there's only one extension, we get the extension and we invoke the correct factory to produce the correct inspector. So this injects the dependency for the inspector class. Now these else's don't really apply here. This code was copied from the draw call, so this is something that would have displayed every frame. We still need it to display every frame, but we'll have to do this in a slightly different way. So I'm going to cut this out. It doesn't have a place here. So here the responsibility is solely for constructing the correct inspector. Hey Jola, welcome back. That wasn't too long. Did you get any sleep? And who lied about what? Oh, about how long I'd be on? Yeah. I thought I was done, but I'm not quite. So I think I really wanted to get file serialization done today, but I think that this refactor, while it's important, I think that it's probably going to be the last thing I do today, and then I'll move on with my life. Okay. File inspector reset. Draw. You said you're going to go offline 1 hour ago. No, I was thinking like 5 o'clock, so that would have been 20 minutes ago. Is when I expected to be off. Yeah, this wound up taking longer than I thought. So I need to be able to display the correct error message when there's no file inspector. So let's take a look at this section. So if there's a current file inspector, we will do the GUI. Else, we'll have to figure out the correct place to do these messages. Yeah. I know we were talking about proper self-care too, and I went and did this. I went and became a workaholic. But I'm on a roll. I'm so close to getting this figured out. Okay, this needs to be okay, like that. Okay, so we have 2 error messages we need to worry about. We have the no inspector registered for a specific extension, and we have to do the multiple selections selected. So we'll need to store number files with extension. We'll probably want to store this as a static somewhere. But not as, So previously we were populating this specifically for that message to say how many we've got selected. the more food in your stomach, the more the more food in your stomach, the more brain you got. That's exactly what I said. But I'm not hungry yet. I don't know. I'll get there. I know a lot of Twitch folks have like redeems that are just like you give up your points so that you can order the person to drink water. My tea's cold. But I don't have such a thing. Hydrate. If I ever got affiliate, I don't know what redeems I would want to do. Some have dehydrate. How do you dehydrate? Like go and pee or? No alcohol. Oh, that's a good one. That's far better. Okay, so I populate a map, number of files with extension, as I parse through the selected files to get the extensions. It makes sense to populate this with a map, to actually make a map structure, but yeah, I think I'll actually keep all of this the same. What I'm going to do is I'm going to take this and make it a static global. Move it down into the namespace though, so it's in scope. And then this, I'll just need to reset it somewhere here. Where did I just pull the line from? Right underneath extension counts. Yeah, so right underneath where we do extension counts equals 0, where we change the count, we'll say number of files with extension dot clear that map out. Code comments be like, I don't know what this is. I was literally drunk when I wrote this code. That's specifically why I don't do it anymore. Though I used to be totally fine with like after work I would be drinking and coding at the same time, and I used to think I was productive that way. I really wasn't. But I did have fun though. That's true. Okay. So number of files with extension. This map is now going to be around. It's going to be persistent, so that way I can display how many files I've selected with which extension down here. I think that makes sense. I think that's probably fine. but I am still carefully reading the code to make sure that I haven't forgotten something basic. No, I think that's fine. So down here, where we're doing the error messages, if there's no file inspector, the question is whether or not, like, the question is whether or not we're selecting files. So if no files are selected, then we'll just skip the current file inspector. Oh, you know what? I have a solution for this. I think I know what to do. I'm going to not make this a static. I'm going to bring it back to being a local. I will, eventually. See you later, Jola. Have a good sleep if you're going back to bed. All right. So what I'm going to do is I'm actually going to, and this is the rabbit hole that is object-oriented programming. I'm going to make another inspector class. So what I'm going to do is I'm going to do a file inspector that's only purpose is to display which files you have, or which file extensions you have selected. And then in the event that you have more than one selection, more than one kind of file extension selected, it will, instead of calling the factory for a particular extension, it will simply instantiate the multi-select inspector. And that does give us a little bit of leverage. Like, it gives us a foothold for doing cool things like in Unity, for example, if you select multiple types, you have the ability to narrow your selection. We could do an interactive widget like that. Yeah, so I think I'll do that. Let's go to the File Explorer and we will just add it. So it's underneath Views, probably. Views. I'll add a subfolder in here for inspectors. No, I'll just do another header CPP file. The guy I was talking to was trying to reach a method in an object. So I was trying to tell him to use static or a constructor or a setter. It made me rethink that it's not that simple when you start around OOP or even JavaScript. Trying to reach a method in an object. Well, I mean, like, he was trying to use a object method, or he's trying to use a static method. So they're not interchangeable. I think polymorphism is it's one of the great powers of object-oriented programming. It's one of the reasons why you would use it, and it's the thing I use for a state pattern because it's perfect. You can instantiate functionality, right? But I think a lot of people get in the trap where they think that if they want to have something that's functional, that they gotta make a class for it, and that's not true. New file. This is going to be multi-select inspector.h. Do proc mod once. Once I said he was trying to use a public method in a class, but had a hard time to pass around the class he had previously created. Yeah, it's yeah, in Unity in particular, I think I'm able to put the finger on where learning how to code through Unity becomes a problem. And it's probably less about Unity and more about the .NET framework. Probably more about how C# works to begin with. And especially garbage collection. Garbage collection is hard to understand until you have worked in a language that doesn't have it. Beginner mayhem. We all went there. Yes, everybody has been a beginner. Except for Chuck Norris. Chuck Norris started out knowing everything about everything. That's a deep cut, huh? What's the last time you've heard a Chuck Norris joke? All right, so we're gonna need to do this. This will need to be a multi-select file inspector. So let's say multi-extension file inspector. Got the Chuck Norris joke in. Yeah. I'm having trouble thinking about Chuck Norris jokes right now. I think it's like Chuck Norris attacks sharks when he smells them bleed. That's the first one I can think of. That used to be all the rage back in the early 2000s. I completely forgot about Chuck Norris jokes. When a snake bites Chuck Norris, the snake dies. So, my include paths are not working because I didn't include this inside of the... Yeah, let's do that. So this is going to be based off of the file inspector header, which is inside of the engine layer. So actually I need to go to the CMake list for the editor, quickly add that header, and we'll have to add a CDP file for it as well. I'll do that first. Multi-extension file inspector.cpp. And then in the CMake lists, underneath the inspector, I'll probably reorganize this later, but I think I'm only going to have like two custom inspectors inside of the editor layer. The rest of it's going to be in the engine layer. So this would be, what did I say? Multi-extension file inspector.h and .cpp. Save. That should generate the build system. Okay, configuration went fine. And this one will do include views. Multi-extension file inspector.h, and then in here we'll do namespace editor, and then we'll do include enterprise. Actually, it'd be enterprise slash editor slash file inspector.h. And then in here we'll do a class based off of the file inspector. So class, this will be multi-extension file inspector, based off of a public file inspector. Okay, and seriously, I'm having a hard time with lambda expression and generic coding templating. Every time I see TKV encodes, I panic. Yeah, it's like for templates in C++, for me, that like freaked me out for a long time too. But it's actually a lot more approachable than I used to think. In fact, there's actually only a handful of concepts you need to know to understand how to do all of the template programming. But yeah, getting over that hurdle of seeing a whole, because it looks like a whole different lexicon, right? You got template, and then all of a sudden you got angle brackets. What's that about? Like, you don't use angle brackets anywhere else in the language and stuff like that. But yeah, and also it's confusing because if you know what a generic is, then you're confused about why they look the same as templates, but they're not the same thing in C++. And yeah, every language has its quirks. Metaprogramming is a hugely important thing, and it's actually one of the things that makes me most excited about the Jai language, the Jonathan Blow's JAI language, is that you have arbitrary code execution with the compiler. That's just going to be so helpful. Whereas inside of C++ and C, you have to do macros and or templates. And they're messy. They're just messy. And no reflection. Okay. I'm starting to get a little slow. But I'd really like to get this done before I go off stream. Okay. So, in the file inspector, we have these methods. I will paste them in here. The init call normally accepts the selected files. I'm wondering if I could... You know, I don't have to call init. That just occurred to me. I can make this an empty function. First, let me do this. But in the case of the inspector, when we don't have a file or a single file extension figured out, then we can simply avoid calling init. It's going to be a little awkward because we have to do basically an empty function body, but it could work. I'll just do the braces here, and then yeah, okay. Oh, thanks. I love your code. It's really clear to me, even with my low-level C++. I'm glad to hear it. I try my best to make it. Like, I mean, I spend you see how much time I spend like agonizing over what I should call a function, what I should call the parameters or whatever. And the main reason is because I anticipate folks who are not very good at C++ programming will be trying out this engine, and I want them to be able to just be able to look at it and then see what they're doing. But that thinking has led me to do all kinds of refactors and re-implementing things that I had done before, and it's slowing me down, but I think it'll be worth it at the end. Okay. So, yeah, I don't think we need cleanup either. Cleanup is not pure virtual, so I can just not do it. Init, I think that for the general use case of file inspector being a parent class, I think it makes sense for init and on inspector GUI to be pure virtual, to force people to implement these functions, because that's kind of what the file inspector class is for. I'm kind of just abusing it to do something slightly different in the editor layer. Okay, so this is looking good. So literally all we need to do is do on inspector GUI. Oh, I need another member function. I'm going to say void init extension list. I coded with a teammate that had a huge knowledge of C++. I believe he was doing unreadable code on purpose. Yeah. It's really easy to, and that's the thing I don't like about C++, is that it's really easy to write hard to read code. It's much harder to make stupid looking code in a language like C# or Swift. Okay. I'm actually going to go ahead and give myself a hard time limit, like Jolo was thinking. I'm going to say that if I'm not done in 22 minutes, then I'm going to get off stream and then do the rest offline. Because this wound up being a way bigger task than I thought it would be. Yeah, so, well, hey, maybe I should think about this a little bit more. So the inspector that I'm coming up with right now is essentially this one. in Unity, when you select multiple file types, it says you can narrow the selection. You got 4 objects, 3 cube maps, 1 texture 2D. I'm effectively making this state. So if I was to do something like that, maybe I would want all of the files. Maybe I actually want the full file list of selected files. If I did that, if I had a full list of selected files, then I could no, I don't think I need the full list of files. It's kind of, this is a UX question, and I'm not really decided on it. I know that I want something like this, where I can deselect the things that are of the wrong type. So I can select all of the items inside of a file, or inside of a folder, and then say, just give me the cube maps, please. I think that's really powerful. But I don't think I need it to display the names of the files. Yeah, so I'll do it. I'll do it like I was doing before. Init will be accepting. Init will be defined because it has to be, because it's based off of file inspector, and I do want file inspector to implement to force people to implement that on the game layer. But on this side, I'm going to have a secondary init function that's going to take the std map of std strings, and this would be the extensions. And what it will do is it'll simply populate the private member std map std string extensions. And I don't do a whole lot of object-oriented stuff on stream, but my style is that when I do a member variable, I will usually put an underscore in front of it when it's private, to make it a little bit more obvious. What's going on? We'll do include map and include string. Technically, I should include set as well. Set and string are transitively included from file inspector, but yeah. Okay. Oh, I need to give this another name. And so instead of being init, wait, can I just do an overload like that, or is it going to complain? Too few arguments for. Yeah, I need a key. So size t would be the counts. And I probably should name it extension counts instead, because this is going to be the association between the extension string and how many there are. Okay. And you know what? I could probably just say extension counts, extension counts. It's kind of all we need there, isn't it? Oh, except for this isn't a constructor, so I can't do that. I would just say extension counts like that. What's up with you? Oh, I need some colon. Alright. So there's no reason for me to not simply declare this, or define this in here. Call of object of class type with that appropriate operator, or conversion functions. Oh, whoops. to say equals, like that. And that'll initiate the copy constructor automatically. This is a const reference, and this is a... What are you complaining about? Oh, it's just tells it's running slow. Alright, and then this is the only thing I need to define in the CPP file. So let's do that. In here. So we'll do namespace, EP, or editor. And then we'll do the definition for multi-extension file inspector on inspector GUI. And then type. Like that. Alright. And then we have the extension counts. Basically, we just include the message that says that you have multiple multiple extensions selected. And that's going to be from the code that we had in here. Here. Multiple IMGUI text, multiple extensions selected, and then we iterate through the map and display them all. I'll cut this out, paste it in here, include my IMGUI.h. Alt Shift F to do the formatting. Number of files with extension is now a member variable. Extension count. Extension counts. Right. So we iterate through this map using C++ 17's structured bindings. We get the reference to the extension string and the reference to the number of files with that extension string. And then we simply do the text. Okay, good. That's looking good. And I'm going to do a to-do note. I'm going to say implement filter UI. So this would be the place. This function call would be the place where we do this functionality, where you can narrow by clicking. But for now, we're just going to skip it. We're just going to display the message. Cool. So that is dandy. We simply overloaded init with a different type. So inside of the inspector.cpp, on selection changed. Here we have gone through all the files. We've populated the number of files with extension. I'm going to rename this here as well. Extension counts. It's a little bit less verbose, a little more clear to understand. Oh wait, extension counts is already a thing. That should actually be extensions count. Because this is counting how many extensions there are, and this is counting how many files each extension has. And we keep this around because it's easier to keep it as a separate variable than to count the number of keys inside of a map. That's not a lookup operation, I don't believe. I don't think, right? Count. Yeah, we pass in the key to count, but we can't get like number of keys or something like that. Okay. Good. At the end of this for loop, we have all of the extensions figured out. If there's only one extension, we do the correct factory call to produce the correct inspector. Else, if extensions count is greater than 1. Yep. Then we will do the mixed version instead. So to do this, we'll do current file inspector dot in place. The type will be multi-extension inspector. And then we just do close parentheses. I need to include the header to get the correct extension in here. So that will be include use multi-extension inspector, and then this type should be filling in, unless I spelled it wrong. No, I didn't. And then we have the multi-extension file inspector. However, it still needs to be told what the extension counts are. So to do that, we'll need to do current file inspector dot as, and this is going to cast it as the multi-extension file inspector. And then we can do dot init and use that overload that's specific to this one class. So we can pass in the extension counts map, which is going to be file inspector factories. Wait, that's not right. Which is going to be num of files with extension. And that's it. So now the init call here will take and save what was a temporary map into the private member storage for this class. However, I'm going to take this a step further. I'm going to make this accept a R value reference instead. And this is a little bit advanced. So what I've done here with the double ampersands is instead of passing a const reference, I'm passing a reference that I'm passing a reference that the assignment operator will interpret as a temporary. So we're not copying when we pass the extension counts parameter in. It is still a reference to the stack variable. This guy, the num of files with extension, still stack declared here. But what the assignment operator is able to do when you go to assign it is it should be taking in, hang on a second, extension counts, operator const std map. Oh, that's a problem. That's annoying. What I was thinking it should be able to do is use move semantics to not reallocate the contents of the map. Because the map is its contents is technically dynamically allocated, even though the variable is stack allocated. So move semantics would mean that it would take this, the contents of this, and simply change the pointer inside of the member to point to its contents, and then it won't delete when the stack allocated one goes out of scope. I'm going to quickly double check that std map works with this. I'm like 90% sure that it does, but for some reason IntelliSense seems to be getting the wrong operator overload. Oh, I can't remember what It's in utility. That's the one. Wait, this is the wrong file. Here, utility. Wait, utility is part of my precompile header, isn't it? Oh no, I guess not. I guess it's not. So it should be. So let's add it. I'm adding utility to give me access to std_move, which std_move is basically like a helper function that takes and makes a it casts a L value reference to an R value reference. Among other things, it's a little more complicated than that. And I don't fully understand it, but I'm using std_move when I pass the variable into the init call. So this is expecting a R value reference, and in where was I? Here. I'm using std_move to cast this to the correct type. And that got rid of the red squiggles here. However, in the init call here, this assignment operator. Oh, hang on, it's changed, hasn't it? It's no longer saying const reference on it. So maybe IntelliSense was just being slow. Let me reread this. So this is an inline assignment operator. It returns a regular std map reference. Oh no, it is accepting a const map reference for the right hand side. So this is the copy assignment operator. Yeah, so let's go back to std map, and I'm going to take a look at its assignment operators. So there is a move assignment operator. Replaces the contents with those of other using move semantics, i.e. the data in other is moved from other into this container. So it should be using it, but I'm going to say IntelliSense is maybe just telling me the wrong thing here. It does say +2 overloads, so maybe it's not actually telling me which overload it's detected it's going to use. But yeah, so we're using it correctly, apparently, but whatever. So the idea is that when this comes in, std_move makes it an R value reference. So this function will treat it like a temporary, and then inside of here, the assignment operator has an overload that takes the R value reference, and then instead of copying the contents of this into that, it will simply rewire things so that this now contains the contents of that. However, having done this, I have to be careful that I don't reference the contents of this afterwards, and it doesn't look like I do. Because when this goes out of scope, after the move semantics is done, its contents should be empty. It should be in a valid state. So yeah, I think we're good. I think that's that. So now we've got the multi-extension file inspector set up. So if we have one extension, we do the factory to get the correct extension inspector. If we have more than one, then we'll do the multi-extension file inspector. Otherwise, nothing happens, and we have an empty current file inspector. Perfect. Let's take a look. What's this complaining about? No matching function call to the type of std map basic string blah 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 blah. I think that this is a warning left over from the previous compilation that just hasn't been cleared out yet, so I'll ignore it. And then down here, okay, this is the other message that I cared about. So if we don't have a inspector registered for the extension we have selected, I wanted to print a message. Oh, you know what? We're gonna do yet another inspector. I think I am on a roll here. But you know what? That's my time. It's 6 o'clock. Or sorry, not 6 o'clock. It's 6 hours. So I think I'm gonna go ahead and call it a stream here. I wish that I had finished this before the time ran out, but I'm just gonna have to take a break and then finish the rest offline. But yeah, so the current plan now, at this point, to get this no inspector registered for this extension message figured out, I'm actually going to do something a little different. I'm not going to make it an error message. I'm just going to make a generic inspector. So that means that if I go to select, I'm going to use Unity as an example again. If I go to select something that doesn't have a custom inspector registered to it, and I'll probably be hard pressed to find one inside of the files I've got loaded up here. Like folders would be one maybe, because folders doesn't have anything in it. Well, folders has asset labels though. I guess everything does. But if I was to take and put a proprietary file in here, and I'll just quickly come up with one. I'll take and drag and drop a EP project file inside of textures. This here is a generic file with no import properties to speak of in Unity, but it still displays the name and so on and so forth. So what I think I'm going to do is I'm going to have I'm probably going to have a generic file inspector that will load in the event that there are no files selected, or no file extensions selected with a custom handler for them, and then that'll kick in when extensions count equals 1, and there's no factory registered for that extension. But yeah, that's the plan. Thanks for tuning in for everybody. I don't know who's left right now. I'm on the fence as to whether I'll be back tomorrow. I feel like I probably will be. I'm kind of on a roll right now, and I want to keep this up until I have something I can show off. But yeah, see you later. Thanks for coming in. Hi Nobi. Bye Nobi.